Chapter 8. What are the opportunities for librarians? 8.1 Introduction. In 1989, Edward Feigenbaum, the father of expert systems, observed in the paper Toward the Library of the Future that the problem with the then extant libraries was that the books did not talk to each other. Feigenbaum, 1989. He continued,
Imagine the library as an active intelligent knowledge server. It stores knowledge of the disciplines and complex knowledge structures, perhaps in a knowledge representation formalism yet to be discovered or invented. It can reason with this knowledge to satisfy the needs of its users. These needs are expressed naturally with fluid discourse. The system can, of course, retrieve and exhibit. That is, it can act as an electronic textbook, but it can also collect relevant information, it can summarize, it can pursue relationships. It acts as a consultant on specific problems, offering advice on particular solutions, justifying those solutions with citations, or with a fabric of general reasoning. If the user can suggest a solution or an hypothesis, it can check it. It can even suggest extensions, or it can criticize the user's viewpoint with a detailed rationale of its agreement or disagreement. It pursues relational paths of associations, to suggest to the user previously unseen connections. Collaborating with the user, it uses its processes of association and analogizing to brainstorm for remote or novel concepts. With more autonomy, but with some guidance from the user, it uses criteria of interestingness to discover new concepts, new methods, new theories, new measurements. Feigenbaum, 1989, 122.
Feigenbaum is addressing a certain kind of library here, what would be called an academic library or research library, and those categories might include university libraries and medical libraries. There are many types of libraries, including academic libraries, children's libraries, digital libraries, medical libraries, national libraries, public lending libraries, reference libraries, research libraries, special libraries, university libraries. See Wikipedia 2023H, American Library Association 2007, for a description of some of these and an explanation of their functions. The librarianship activities associated with these are many and varied, and there are also other librarianship activities not connected with institutions specifically of these types. For our purposes, as a practicality, we have to restrict our gaze. For the most part, we will be looking at machine learning in connection with scholarship, research, and advancing knowledge, i.e. with Feigenbaum's approach of relating AI to the notion of a library as a knowledge server. This means that our main focus will be academic libraries, including university libraries, medical libraries, and research libraries. We also often consider librarianship in general. There may be the odd remark on machine learning in other kinds of libraries, as examples, that humanoid robots may be valuable for children's story times in public libraries, Gwyn 2020. And that handwriting recognition may be valuable for the Vatican Archive, which is a special library, D. Firmini et al. 2018, but coverage of these areas is going to be thin. Sorry. There is the idea of collections as data and data as collections, with librarianship as an interface. See, for example, Padilla et al. 2019. Standard libraries can be thought of as collections of texts, documents, and books, and also, perhaps, of means of access to the same or similar items. Some, or many, of these collections, or parts of collections, will be born digital, or become digitized, and will be available to computers, artificial intelligence, and ML. Thus, there is the notion of collections as computer data. But also, we now live in the age of big data. Huge amounts of data are being accumulated by researchers, governments, social agencies, and commercial interests. Many subsets of this big data are collections. They are libraries. They are subject to the ordinary concerns of librarianship, such as organization, preservation, storage, access, retrieval, and stewardship. So, there are collections as data and data as collections, with librarianship as an interface. For example, researchers in astrophysics, with their telescopes, radio dishes, and myriad of other instruments, produce data repositories that stand in need of librarianship. Then, still in their day job, these researchers read research papers in journals and collections. Provision of these also needs librarianship. There is an abundance of modern digitized, or born digital, resources, and this abundance is growing rapidly all the time. There is a plethora of sources spewing ever more zeros and ones. Facing up to this on behalf of librarianship are a relatively small number of expert human librarians. There is an order of magnitude difference here. The potentially valuable tasks and the collection sizes far outweigh the capabilities of a team of human librarians, even if the number of librarians were to be increased 1,000,000-fold. As an example, which is becoming slightly dated, there is the mesh indexing of biomedical publications. About 7,000 articles a day were being indexed. Yuqing Mao and Jion Lu wrote,
Mesh indexing is the task of assigning relevant mesh terms based on a manual reading of scholarly publications by human indexers. The task is highly important for improving literature retrieval and many other scientific investigations and biomedical research. Unfortunately, given its manual nature, the process of mesh indexing is both time-consuming. New articles are not immediately indexed until 2 or 3 months later, and costly, approximately $10 per article, Mao and Lu 2017.
There is a general point to be made here, the same general point as will be made elsewhere over and over. Computers have a 24/7 work ethic, and ML can often supply expertise. Many areas have been automated already. But this is an ongoing and expanding process. Of course, human librarians use many tools to increase their capabilities vis-a-vis librarianship, but we are moving into an age where the ML systems on their own can produce excellent performance, maybe even superior performance. Librarians already work with many systems that have connections to AI and ML. Here's one way to classify librarians working in AI or ML and roles. Librarians can be seen as synergists, sentries, educators, managers, astronauts. Individual librarians may fulfill different roles on different occasions, or, indeed, be working in different roles at the same time. 8.2 Librarians as synergists. Librarians have several thousand years of experience of working with recorded information. They are ideal partners to AI to bring out the best in this information with all its aspects, challenges, and facets. And, on the other side of this, there are many AI and ML technologies that have the potential to improve librarianship. There is an opportunity for synergy or symbiosis. We will introduce a few sample possibilities here and expand on the topic later in a dedicated chapter. Synergists. A. Intellectual freedom. AI, ML, and librarianship have potential to enhance intellectual freedom, both the expression of free speech and access to it. As examples, optical character recognition leading into machine reading and speaking of text, and, separately, machine translation of text leading to recorded text being available in many languages, Knox 2023. Machine learning is now expanding these possibilities to hundreds, even thousands, of languages. B. Smartphones. Many young, and not so young, people use smartphones as their main means of access to information. This opens an obvious invitation to librarians to bring libraries and librarianship to patrons via smartphones, e.g. via a bundle of voice and sound, static and dynamic text, and images and video. This might involve AI, ML, and chatbots. C. Improving intermediation between users and information resources. As examples, search engines rank their returns, from more important to less important, and, separately, there are recommender systems which can recommend other resources similar to ones favored by the user. Pure librarianship does not have either ranking or recommending in any developed form. Even the computer, or AI systems, versions have not yet realized their potential. D. Improving traditional cataloging, classification, and retrieval tools. Standard point: there are, and always will be, fewer expert human catalogers than are required to address the increasing flood of resources. Computers and ML can redress this. Also, NLP can perform valuable librarianship tasks that are not practical for humans. For example, it could look at 1 million publications and identify, de novo, what subjects, topics, or genres each might be labeled with. De novo here means without using any antecedent classification schemes. Chatbots. Chatbots have the potential to do most of the current tasks where librarians interact with patrons either synchronously or asynchronously, e.g., in person, on the telephone, on video calling, by messaging, etc. Release, produce, curate, or inspire the production of training data. Librarians already have metadata on the contents of libraries' metadata which, for the most part, is accurate and labeled well. Also, librarians are well placed to use handwriting recognition on archives of historical documents. Developing handwriting recognition for these will require the production of data, most likely labeled samples. G. Social epistemology. The promotion of social knowledge. Social epistemology is a vital function of librarianship. Egan and Sharon 1952, Fawless 2002, 2006, Fuller 1988, Goldman 1999. It is a function that librarians have been doing for millennia. Social epistemology faces problems aplenty nowadays with disinformation, misinformation, fake news, deep fakes and the like, Mazzaros and Goodset 2022. Librarians, in conjunction with the tools of ML, are well placed to take on the challenges. There is now the opportunity, and the need, to do more. Images. There are libraries and collections of images, for example, the Center for Creative Photography in the University of Arizona, CCP 2020. Also, many publications contain images, figures, and diagrams. Attaching metadata to the images and then finding the desired images has always proved difficult. But now ML is allowing it to become possible for standard librarianship operations to be performed on media like images. For example, you can now enter an image itself or a verbal description of an image as search terms, and a suitable search system will be able to find all similar or relevant images within a document or collection. These possibilities would be enriched by insight from librarians. Images are getting to be addressed reasonably well by ML. Jason Griffey asks an interesting question in connection with synergy. He introduces it by way of recommender systems and improving personal intermediation.
One can easily imagine systems built to do this sort of automation work for researchers and students. As AI systems continue to be easier to implement, having a system local to your device that learns your preferences, your interests, and your needs will be commonplace. Researchers and students will have AI systems that find sources for them, summarize them, help them build bibliographies, and more. Over time, these systems will become irreplaceable archives of the learning and thinking history of individuals, a sort of universal diary of their activities. Now, imagine for a moment that this sort of system exists and is used by most learners. Who would you prefer be the developer of such a system, a large corporation like Facebook, or a collaborative effort by educational institutions and libraries? Griffey 2019, 27, italics added.
8.3 Librarians as Sentries. Unfortunately, many of the potential benefits of ML and librarianship have concomitant downsides. Here the librarians can be sentries. To anticipate, The challenge is that advances in ML have been so rapid that suitable ethical systems, laws, and policies either do not exist or are out of date. Librarians can help create these. Centuries. Here are some examples. A. Copyright and intellectual property. Intellectual freedom interacts with restrictions of privacy, intellectual property, state secrets, and so forth. These considerations required careful management, and librarians have plenty of experience with, for example, intellectual property, fair use, and licensing. B. Bias management. There are various kinds of bias that can arise in connection with ML and information provision. Librarians do have experience in managing bias. For example, they do it in collection development, collection description, instruction, and research support. Padilla 2019. C. Monitoring techniques to improve search methods associated with personalization and recommendation impinge on privacy by, for example, monitoring users' behavior to create the personalization. Filtering has had a bad reputation within librarianship, primarily due to misadventures involving filtering schools' access to websites. But, when doing a search, providing recommendations is filtering. Then filtering can lead to information silos or bubbles. There are problems here to be addressed. D. Intellectual freedom. This needs management. The collections and services should presumably give patrons access to a wide range of diverse and thought-provoking materials, while also protecting them from potentially harmful or offensive or false or ungrounded or obviously crazy content. But how to do this is a question. One person's crazy might be another's happy territory. And the idea of protecting introduces parentalism or paternalism, which should not be required for fully functional adults. Machine learning systems could very easily work in a paternalist way. E. Inadvertent censorship. The properties and behaviors of advanced machine learning systems, for example, those built from foundation models, are usually not fully known. Caution is needed to ensure, for example, that there is not accidental censorship. 8.4 Librarians as educators. Librarians have a role as educators. Educators, A. Information literacy. Librarians have always been the standard bearers for information literacy. But artificial intelligence, AI, has changed what information literacy can be. There is ongoing development of new tools for interacting with information, for example, personalized search. AI or ML, as research disciplines or commercial enterprises, devote little or no attention to information literacy itself, except insofar as the AI or ML can be a part of any educational course or teaching on any discipline or topic. B. Data literacy, data science fluency, and AI literacy. There are other forms of information-related literacy that are becoming important. Ridley and Pollock-Potts 2021a, Digital 2030-2022, Druga et al. 2019a, Carlson and Johnston 2015, Padilla 2019. For example, research scientists are often required to have data management plans. They are producers of data, and they need to know how to manage it for the benefit of other researchers and the world at large. Librarians can help the researchers directly and also play a role in educating student researchers in the management of data. Another example is that AI and ML have expanded the realm of automated decision-making, ADM, e.g. the making mortgage loans. An informed citizenry should be alert to the strengths and weakness of ADM, C, more intelligent consumers of information. This includes both patrons and library staff. D. Better informed citizens. Outside of actual information literacy, there are considerations of helping citizens understand ML and computational aspects of the world they live in, and, in the case of living in the USA, how some other countries are approaching it. As examples, there is the Canadian Algorithm and Data Literacy Project, Digital 2030-2022, and there is the European Generalized Data Protection Regulation, 2018.
2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 2018. 20
8.5 Librarians as managers. At a perhaps a more day-to-day level, librarians run libraries, both physical and digital. Computer-assisted automation is widely used and is of obvious benefit. Book acquisitions, cataloging, serials control and circulation, information retrieval and dissemination, interlibrary loan, cooperative acquisition and cataloging have been automated in the library. Lakshmikant and Vishnu, 2008. AI can improve the running of libraries. We are trying to steer clear of plain automation in this text. We will try to restrict ourselves to cases where the software uses or simulate artificial intelligence. Managers, a workflow and improving service. ML has the potential to enhance productivity and efficiency in libraries. Many of the components here have been mentioned already: ML cataloging, personalization, recommender systems, better search, chatbots for customer service, predictive analysis for collection management, user behavior analysis to improve service, and digitizing special collections. B. Optimize the use of space, and, indeed, other resources. ML is good at optimization problems. C. Robots to put books back on the shelves, to do storytelling, to meet and greet, and more. D. Mimic librarian experts' behaviors to support decision-making and management. 8.6 Librarians as astronauts. Astronauts, well, who knows? But most of human knowledge is in libraries. ML will allow exploration here of a kind that has never been done before. Astronauts, A. Creating knowledge. There is deep text extraction and synthesis from materials already in libraries. More than a few university researchers conduct their research using only their initiative and the contents of libraries. ML will be able to do this and render the faculty researcher redundant in this regard. B. Drawing out knowledge. There are many special collections that have not been digitized and transcribed, and, perhaps, for more than a few of those that approach might not be acceptable. But processed collections with indexes, for example, might provide access to treasures. C. Moonshots? Who knows what they might be? Chapter 9. Librarians as synergists. 9.1 Intellectual freedom. Intellectual freedom is the right, and perhaps the ability, to access or disseminate any information that the person wishes. Now, there are many qualifications here, obviously, such as those concerning privacy, intellectual property, offensive materials, state secrets, etc. Let us build on the restrictions and consider only those cases where there is a right to freedom of access or to freedom of speech, i.e., to freedom of dissemination. Then let us concentrate on the ability to exercise our rights in those cases. It is reasonably common in rights discussions to distinguish privilege rights from claim rights. When our 2021. A person has a privilege right to do X, if, and only if, they do not have a duty not to do X. So, a mature person presumably has a privilege right to read, say, Huckleberry Finn, and that right exists because they do not have a duty not to read it. Additionally, a privilege right is a freedom to the rights holder, which does not impose any obligations on any other party to facilitate that right. If you have a privilege right of freedom of access to some form of information, you may access that information, but no one is obliged to give you practical help to do so. Claim rights, in contrast, impose a duty on some person or entity to actively assist a person to exercise the right. For example, some folk might not be able to afford to buy, or simply might not wish to own, some of the books that they are interested to read. In these cases, libraries, perhaps public libraries, can facilitate a claim right of access to those resources. In contrast, booksellers or bookstores are not subject to a claim right of access. In the absence of purchase, or similar, from the would-be reader, they do not have a duty to provide access. Libraries, especially public libraries, aim to satisfy claim rights of access. Some also may provide a physical public space for meetings. This would be assisting with disseminations, perhaps even assisting with claim rights concerning dissemination. Libraries, or librarians, also often are active in opposing banned books. Third parties might want copies of, say, Huckleberry Finn, removed from a library. What is happening here is that the third parties are partially denying the claim rights of others, and possibly also denying the privilege rights of others. Librarians are defending these rights. So, librarians help meet some intellectual freedom rights and defend others. Garner and Magi 2021, American Library Association 2008. How machine ML help with this? The short answer is, librarians need to provide direction as to what they wish their policies to be by way of addressing rights of access and dissemination. In the past, they have provided such direction, and they continue to do so in the present. But the landscape as to what is possible is changing rapidly, so policies require ongoing attention. ML cannot really help with what the policy should be. But once the policies are in place, ML can certainly help with the implementation. Here are some details. 9.1.1 Text Recognition. Text recognition has been an absolute triumph in enabling people with visual challenges or reading difficulties to access written and printed materials. In a library setting, text is understood to be recordings that are written or printed or reproduced, pieces of language that can convey meaning. These recordings can range from handwritten documents to professionally printed books, from documents thousands of years old to those from the present day, from originals to photocopies of photos pasted into a painting collage. The recordings have a form, and mostly they have meaning. Text recognition is trying to capture the structured form of the text as computer input, and not the deeper meaning. For example, consider the text "Now, I am angry." What text recognition needs to be able to do is to pick the letters in sequence, i.e. N, O, W, etc., to pick the words, likely from the separators such as the blank spaces, to pick the sentences, likely from the uppercase letters, periods, and punctuation, etc. It does not need to be able to grasp what the text means, e.g. what or who the indexicals like I and now refer to, or what the word angry means. Two further points should perhaps be made. Text recognition's main line of business is not that of helping people who are visually challenged, rather it is that of helping large corporations and institutions convert their paper records and data into digital form. Assisting the visually challenged is a happy side effect of that enterprise. Second, complexities arise with OCR over whether the source documents are monolingual or multilingual, and consequently the various alphabets, orthographies, and grammars that might be in use. See, for example, Alfred Abrams 2016. It is possible for target sources to be multilingual. They would constitute additional challenges. Multilingual sources are not common, but they certainly can appear in older materials where there might be a mix of a scholarly language, e.g. Latin, with a vernacular, e.g. Italian, French, English. Consider an older handwritten text, written in several languages, and which uses loan words, i.e. uses or quotes words from other languages. Adequate OCR here might require relevant outside knowledge, for example, of the provenance and cultural background of the document. As mentioned earlier, most modern publications exist at some point in digital form. If there is access to that digitization, text recognition is not needed. So, generally speaking, text recognition for library purposes is not as important now, 2023, for modern materials, as it was, say, for materials produced prior to the 1980s. Also, the use of a variety of fonts and printing styles, which make text recognition harder, are a modern development. That help is to some degree offset with other problems with older materials, such as difficulties with ink fading, poor printing, deterioration of the paper, etc. Nevertheless, the main problem areas for text recognition in libraries are older printed works, where the publishers have a restricted choice of font palette, and, separately, handwritten documents. Generally, printers are trying to print works in a form that the readers can read. They are not trying to distort letters left and right, or larger and smaller in a way that would challenge your readers, or, indeed, OCR systems. The original OCR systems of the 1970s would not have been ML systems, but nowadays they certainly would be. For a discussion of OCR, we can consider just neural nets. Conceptually, text recognition takes place in two phases: the optical character recognition, OCR, and the discernment of structure within the stream of characters. From an ML point of view, OCR is an example of a supervised classification problem. First, there is a classification system, which is a collection of classes, or categories, or sets in this case, that is going to be an alphabet of characters, e.g. A, B, C, etc. Then there will be the characters, or character instances, themselves, which will start computational life as visual disturbances, marks, blobs, etc. on paper or some other medium. Likely they will then become patterns of pixels in electronic images that the algorithms can address. Processing will individuate these into characters of interest, then ML will classify each one of these as being an A or a Z or a J or a space or other character. It sounds simple, but it is not. There are issues and challenges. Let us start with the classification system. There are about a dozen writing systems and hundreds of alphabets, Ager 2023. There is the need to pick one or several here. Which one is chosen presumably depends on the purposes at hand. If a library has primarily English sources, presumably the English alphabet would be a good start. This is not in any way to insult or denigrate, for example, Japanese and hiragana. There are 2 points to be made here. Classification systems usually carry baggage with them. They have assumptions and consequences that extend further than the classification systems themselves. See, for example, Boker and Starr 2000, S. Berman 2000. An OCR implementation might be able to recognize English characters but not hiragana, and that might matter for those who can or cannot benefit from the specific OCR. Second, the choice of classification system or systems might involve a wide range of constituents, not just programmers or AI researchers imposing their will. The patron, user, librarian, research challenge, and infrastructure and legal framework also can provide input. Then supervised ML-OCR is going to be taught, or learn, how to classify characters. It will be supplied with a training set, which will be a reasonable sample of letters and the right labels or classifications of what they are. The training set might run to 100,000 labeled characters. The overall technique is an optical one, so it is the features of the sample letters that can be detected optically that will be the input, e.g. size, shape, color, grid arrangement of component dots or pixels, etc. Then the program will attempt to correlate combinations, i.e. vectors, of these with the correct classification, e.g. that a particular sample token character is an A. More than likely, the program will make many mistakes initially. But either the programmers, or the program itself, will tune various parameters, e.g. weights on the components of the vectors, to improve the classification until it reaches an acceptable level of performance. Typically here the neural net would have 5 to 6 layers and hundreds to thousands of neurons in the layers. The training set needs to be adequate for the task. For example, if the letter J does not appear in the training set, it is unreasonable to expect the ML program to classify JS correctly. Even if JS appear, there needs to be enough of them in the various fonts and scripts, cursive or not, monospaced or proportional, etc., for the program to be able to learn what is correct and what is not. OCR, i.e. the task of recognizing the actual individual characters, would not usually be an end in itself. Rather, the interest would be in the words that those characters form, or, more generally, the text. If the OCR, or text recognition, application has access to a wider context, that can improve its performance. For example, if the ML is recognizing entire words from their component characters and separators, then the first letter of ON is going to be the letter uppercase O and not the numeric letter 00. The number 0 makes no sense in that context. Let us assume going forward that there is ML that can take an input of images, i.e. a page of visual representations of characters, an ordinary book of words, etc., and produce as output text. Now, text, in a computer science sense, consists of strings or sequences of characters, and, once in that form, they can be processed in a variety of ways. For example, they can be searched, or edited, cut, copied, pasted, transformed, etc. To give a practical example of the advantage of strings over raw images, finding the word COVID in some computer science, digital text is near trivial for a computer program. Contrast that with the following. Imagine a photocopy, or photograph, of the front page of a newspaper, and the problem finding whether there is a subimage in it that might be construed as an image of the word COVID, i.e. does the word COVID appear on the front page of the newspaper? That is a much harder problem. You know that, of course, from the online CAPTCHA tests that are used to detect whether you are a human or a program or bot pretending to be a human, Wikipedia 2023a. OCR for modern printed monolingual text is near perfect. There is a qualification here. OCR needs training data. There are about 7,000 languages in the world, and about half of these have writing systems. Of those 3,000 or so with writing systems, quite a lot less have enough printed text to be suitable training data. Current OCR systems can read about 200 different languages. There will be more languages than that with suitable training texts, but there also needs to be either commercial or intellectual incentives for the relevant OCR research to be done. As the text recognition systems have improved, their compass has been extended to include handwriting recognition, i.e. transcribing handwriting to the zeros and ones of computer text. This is very important. To give an example, the Vatican Apostolic Archives, the Vatican Secret Archives, contain hundreds of thousands of documents going back many centuries. D. Firmini et al. 2018, Wikipedia 2022 f. Most of these documents are handwritten, and certainly more than a few of them are of great significance. For example, one is from Henry VIII to the Pope requesting a marriage annulment. Transcribing handwriting is of a level of difficulty harder than transcribing printed text. There are different cases to be considered. There is personal handwriting to be transcribed online, i.e., as it is being written, real-time, perhaps onto a smartphone or tablet. For example, a user may handwrite entry into a text messaging app. There is purely personal, or official, handwriting to be transcribed offline, i.e. from a recorded document after it has been written. Transcribing online is easier than offline because information is available on the pen strokes, their sequence and timings. This information helps, for example, with segmentation, with identifying the lines, the words, and the characters. There can be real-time transcription with the characteristics of offline, for example, so-called scene-in-scene transcription. For example, driverless cars may have the need to read road signs and other textual information that they are seeing. There may also be some value in the ability of a driverless car to read handwriting within its video stream. Some restaurants displayed a menu outside with the day's fare handwritten on a small blackboard. Search applications might want to have the ability to read this from a video feed. For our purposes, with recorded documents, our interest is primarily with offline transcription.
The problem of automatic handwritten text recognition, HTR, persists since document digitization started. Text recognition is a simple task for humans, but it has been proved to be complex for automatic systems. In fact, it is considered an unsolved problem and under active research. The high variability between writers and the cursive nature of the handwriting text are the main difficulties presented by this problem. These difficulties have meant that historically, the practical applications of offline handwriting recognition technologies have been quite limited, Swears 2021.
To a degree, everyone's personal handwriting is different. Nevertheless, mostly, people are trying to communicate with their handwriting, and they have learned, have been taught, or are required, to write in a way that their writing can be read. There are differences in the writers, their writing styles, and their purposes. There are differences in the intended roles of the product documents. Some cases are easier to transcribe than others. There is cursive handwriting and block handwriting, writing separate letters. For example, international arrivals at an airport may be required to handprint, i.e. block handwrite, their flight and passport details into a form, where some of the fields of the form are required to be text, others known to be dates, and yet others known to be numbers. Such handwritten forms can be machine-read quite easily, even though there may be different authors and writing styles involved. Documents like those in the Vatican are often official documents of one kind or another, written by scribes. In cases like these, not only does the scribe personally want the document to be easy to read and definite in form, but so does the scribe's employer, the government, the queen, the seller of the land, etc. Scribes need to get it right or lose their jobs, or maybe their heads. Scribes in a certain cultural setting are usually required to follow a specific style. Roughly, they have to write in a certain font. Most of the medieval and later documents in the Vatican will have been written in the Carolingian minuscule font, or later fonts related to it. Many cases are much more difficult than this. There is a manuscript collection of the works of the English philosopher Jeremy Bentham. Bentham wrote on philosophy and law. He is known mainly for proposing utilitarianism. Bentham wrote the manuscripts largely himself. But he also had helpers who wrote some portions. He wrote mostly in English, but occasionally with pieces in Greek or French or other languages. He made corrections, but often leaving the originals and the crossings out in the text. He also sometimes wrote in columns, or with included passages. However, coming at this from a different direction, think back a few years of your own experiences. A regular high school teacher might receive 30 handwritten essays from students and be able to read them without any difficulty. If there was difficulty, likely the student would be given remedial handwriting instruction. This suggests that ML would allow computers to read cursive or block handwriting from a variety of authors. Typical approaches to this in 2023 would likely involve neural nets or deep learning, and this means, basically, that they could be covered by a foundation model. 9.1.2 Speech-to-text. We are all familiar with voice-controlled assistants like Alexa, Siri, or Google Assistant. These can take speech or dictation and first turn that into computer text. Usually, the way that this step is done is that an ML program will attempt to recognize and classify the phonemes in the input sound. The phonemes are the smallest, or atomic, sound components of speech in a language. In English, there are about 44 of these. In response to dictation, the program will produce a stream of phonemes. Converting this stream into well-formed and sensible text is hard. But it has been done now with 99% accuracy for most well-known common languages. To give some idea of the difficulties. In English, there can be the same letters producing different phonemes, then, these, different letters producing the same phonemes, sit, city, ate, ate. To resolve these, context is required, i.e., what makes sense in the wider sample of speech. Google's Cloud Speech-to-Text V1 supports dictation in hundreds of languages, Google Cloud 2023. Apple's software for iPhone covers dictation capabilities for about 100 languages or their dialects. British, American, and Australian English are all listed separately, for example. Meta's Massively Multilingual Speech, MMS, project is aiming at speech recognition and text-to-speech models that can recognize over 4,000 languages and work with over 1,100 languages, Meta 2023. Meta also open sources its models, which may be good. Of course, recognizing a language is one thing, being able to take dictation in it at speed is something else. The training here is largely with audio recordings which have transcripts. Obviously here resources are meager with rare or unusual languages. If the target language has a text-to-speech converter, that can be used to create data. Speech-to-text can be used to transcribe speeches and lectures. Text-to-speech can be used to create audiobooks. The two technologies can be used to help people learn languages. The two technologies can be used to help people communicate in their preferred language. They can help preserve language diversity and prevent languages from dying. Languages usually die from a lack of use and native speakers. This may come about for a variety of reasons, speakers favoring other languages, government policy, etc. However, the technologies create an infrastructure which retains the knowledge of how a language is to be spoken, written, and read. There are settings where either typing or writing cannot be used or in which they are not the best option. Dictation is usually taken to be much faster than typing or writing, maybe 3 to 10 times faster. There is evidence counter to this in certain circumstances such as start-to-finish form filling in a medical or legal context. Some situations, for example, if there is background noise, are not the best for speech input. But the choice is there. Voice commands, voice input, and the ability to ask questions verbally increase intellectual freedom. Smartphones are ubiquitous. They can take text input and provide visual text output, and some users are astonishing adept at typing their text input. They also can work with sound and will usually have a voice-controlled assistant. Transcribing spoken language into text makes it easier to search. This may be useful for libraries that have audio resources, such as historical recordings of question and answer sessions to a parliament or oral histories. 9.1.3 Sign Language to Text and Text to Sign Language. There are AI programs to translate sign language to text. These will use some means of capturing or viewing the images, perhaps a smartphone. Then they will classify what is seen. This may be done real-time, that is, as the same speed as the signs are being given, i.e., at conversation speed. But classification of, say, the hand movements is not the only challenge. There are maybe 300 sign languages, and they have different characteristics, of course. Usually, a sign language does not consist solely of signs made with the hands. Rather, there is a wider range of gestures, including facial expressions and bodily movements. This makes the translation problem much more difficult. Within libraries and other repositories of information, text, images, and other visual artifacts are the primary display medium. If a person is challenged visually, then text-to-speech technologies are very helpful. If a person is challenged orally, but not visually, then sign-to-text technologies are certainly valuable. But the visual text itself would presumably be available to such a person, and that would provide a means of access to recorded information. There will be cases where sign-to-text technologies would help in a library setting, for example, for those who can sign but not read or write. Libraries do have holdings in sound, for example, podcasts, recordings of lectures and speeches. Transcription to text might help there. We are all familiar with important addresses and speeches being signed simultaneously with being spoken. Obviously, that is a valuable access and inclusion technique. But when the focus moves to recordings, say of the Australian Prime Minister, Julia Gillard, saying, in 2012, "I will not be lectured about sexism and misogyny by this man," there does not seem to be the same need for a signed version. Recordings of the speech are available in video, sound, and text. 9.1.4 Helping filter and personalize. A problem highlighted by Jorge Luis Borges' short story The Library of Babel is that just having access to absolutely all information would likely prove to be useless because the relevant information would not be able to be found. Wikipedia 2023n. Intellectual freedom needs a filtering of garbage and a personalization to provide relevance. ML can provide that. This topic will be revisited later. 9.1.5 Scholarly Publishing. This is a small aside, but it is an example. Researchers in the Western world are more or less required to publish their research papers in English. Many are not native English speakers. There is an awkwardness at this point. Some scholarly publishers provide automatic translation to English for all submissions. See, for example, Choice Media Channel 2022. 9.1.6 What can be done with computer? Text. Suppose, now, that we have the computer text corresponding to a page, or pages, or books of printed or written characters, or of speech, or of signs. What can be done with that? A lot. See section 1.4. 9.1.7 ELI5 Translation. It is common to see the acronym ELI5 on discussion hosts like Reddit. ELI5 means explain it like I am a 5-year-old. An interesting and fascinating point is that LLMs can do this. They can explain passages as though the audience were 5-year-olds. But also they can simplify and re-render passages at any level whatsoever from 5-year-olds to the level that the passage was written at original, and even go in advance of that perhaps to a more sophisticated version. This matters for two reasons. It increases intellectual freedom because it makes difficult passages accessible to all, and it personalizes the delivery of information into a form that the user would like or to a learning style that the user needs. 9.2 Improving the intermediation between users and information resources. 9.2.1 Some users might not be human. Some users might be ML programs or software tools that are employed by the human user or employed by other programs or bots. To a degree, this is true already. For example, many repositories will publish their metadata for harvesting. See, for instance, the Open Archives Initiative Protocol for Metadata Harvesting, Wikipedia 2023J. What is happening here is that services are being built off resources that a library or libraries have, or off services that libraries offer. Librarians can help this by ensuring that their holding are accessible in relevant ways to appropriate users. Accessibility in this context will likely involve considerations of licensing and intellectual property. One type of service that likely will become very important is that of text mining. We will look at text mining later. 9.2.2 Some resources might not be resources. Some resources might not be resources in the sense of being physical or digital texts or documents. They might be services. A library might provide a service, for example, a certain kind of access to its holdings. A second library might provide a similar or different services. A further party might bundle those services into another service. 9.2.3 Digital Archiving. Archiving is a little different to straightforward librarianship in that it deals almost exclusively with historical materials, and its organizational principles are often different, for example, in giving pride of place to provenance. Digital archiving, preserving digital content for future use, is different yet again. It is one of the many things that commercial and governmental institutions do. For example, digital archiving may be mandated for compliance reasons, e.g., keep your tax records for 10 years. 9.2.4 Enhanced Search Engines. Existing search engines already use machine learning. Companies like Google typically do not reveal exactly how their systems work, presumably for commercial reasons. But some techniques are known or can be surmised. Google search uses RankBrain, Hummingbird, Panda, Penguin, Pigeon, etc., along with the original PageRank algorithm, Wikipedia 2023K, 2023L, 2023E. Some, or maybe most, of these use ML. What these techniques concern mostly is with ranking the results that the search engines find. Apparently, there are 200 or so ranking factors that can be taken into account. Some of these are to do with the web pages themselves, whether they contain real content or are clickbait. Some concern the users and their search histories. Some even concern the locations of the search origins. For example, in the US the word boot picks out a footwear item you wear. In Britain the word boot can mean this, but it can also mean what Americans would call the trunk of a car. The search engines know this and can react accordingly. The search engines also use NLP more generally, and there is considerable amount of machine learning in NLP. Librarians have expertise in information retrieval. This could be used to create search engines that are more effective at understanding and fulfilling user queries. There already are image searches, with image input or image output. There are location-based searches. Google Maps tells you of restaurants near you, not those on the other side of the continent. There are possibilities and opportunities here. 9.2.5 Personalization and Recommendation. What an information provision system is trying to do in response to a perhaps not well-articulated request from an individual user is to supply that user with all and only the relevant resources, i.e. 100% recall and 100% precision from a well-defined, or not so well-defined, collection of items. Recall is the percentage of relevant items in the collection that are returned. Precision is the percentage of returned items that are relevant. Roughly, recall is signal and precision is absence of noise. There are explanations and qualifications required here. Frick, 2013, writes, relevance is usefulness to the user as judged by the user. Relevance is just a user-controlled honorific that connects items and utility on a particular occasion of retrieval. The patron or user is ultimately the sole arbiter of relevance. Assume so. This means relevance is subjective in the sense of being user and occasion specific. In turn, this means that retrieval is subjective, and the best retrieval systems will allow for personalization for individual users. Separate from this, the boundaries of a collection may be somewhat woolly, as they may range from a single bookshelf out to a single library, from there out to the entire internet. ML can personalize provision and retrieval by knowing about a patron and a patron's past behavior. Traditionally, libraries have often had advisory services. These usually would consist of one or more librarians who would know the local collection and would have experience of patrons, their information needs, and the resources from the local collection that would meet those needs. The assessment or feedback on their work might be limited. There might be some surveys, or similar, but not much more. Computer and AI advisory services would or could know about many users, many collections, and would have extensive data and feedback as to how it was performing, and improve itself accordingly. 9.2.6 Recommender Systems. We are familiar with recommender systems from our experiences with Amazon for books or other items, and with Netflix and streaming sites for movies. Recommender systems can improve reading experiences. There are various possibilities here as to how these might work, which we can describe in a library setting. Data is needed, and pretty much the more the better. This might include 1. Demographics about the user, e.g. whether they are a child or a senior citizen. 2. any information that they wish to share about their likes and dislikes and preferences, genres, subject matters. 3. Their reading or access history. 4. Information about the books or available resources, perhaps including their genres, abstracts, ratings, or reviews. 5. Other relevant factors. 6. Diversity in plots, characters, authors, genres. There is collaborative filtering, which puts the user in the context of other similar users and recommends on that basis. There is content-based filtering, which pays attention only to the items that the user likes or seems to like and works with their properties, ignoring information about other users. Most systems will use a hybrid of both approaches. One is that an anonymous user accesses or views or reads a single item and remains anonymous, but might have a continuing single session identity. There is not much data to work on here. But the item itself will have many properties, such as author, subject, genre, length, etc. It also might tie into explicit written reviews or feedback from other patrons or even professional reviewers or critics. Some sorts of recommendations might be able to be made here. The continuing session identity might give some feedback as to whether any of the recommendations were followed up on by the central user during that session. More usual would be the setting where every patron's accessing history and every item's accessed history is known and recorded as data. This data can be kept private and identities not revealed. This accessing history will be implicit data about the items accessed. There also will be explicit data about these items, such as their authors, genres, subject matters, reviews, and citations or references or links to them. At this point, either just data about past interests might be used or data about that supplemented by data about other users and their histories. Any ongoing behavior by a user can be used to update their profile. Then, probably either one of two approaches might be made. The first is to put the patron into a stereotype, i.e. a class or group, consisting of other patrons similar in respect to the patron seeking recommendations. This would be done largely on the basis of the present reading and the access history. The other is not to bother with classes and just to let a ML system look for similarities in reading behavior across users. It takes the likes and dislikes of the user being helped, then overlays those on the likes and dislikes of other individual users to produce a match. The upshot can be a recommendation system that helps users with personalized, perhaps ranked, recommendations as to resources that would be interest, useful, and relevant. Such systems can do more. They might be able to predict how new items, yet to be purchased items, will be received by groups of users, the preferences, and thus, in the case of libraries, help with collection development. 9.2.7 Understanding what the user is asking for. Internally, behind the curtain so to speak, a traditional information retrieval system will likely use Boolean queries or queries in a database query language like SQL. But few users are competent to input their questions or requirements in this fashion. See, for example, Frick 2021. Some natural language processing here could smooth the interface between user and such systems. 9.2.8 Text mining. As described in Chapter 7, text mining can extract a variety of potentially useful information from text, such as information regarding named entities, topics, classification features, genres, summaries, and sentiments of reviews. Any or all of these may help a user narrow an information search and thus make it more precise. Going a little broader, text mining can look through, usually large, corpora for valuable information or patterns. The size of the task makes it hard, if not impossible, for humans to do. We have discussed facets of this elsewhere. For example, creating an encyclopedia by ML requires text mining. Question answering, summarization, tracking research ideas, etc. all require text mining. We will discuss the topic again in the context of undiscovered public knowledge. One red flag or alert is over the question of licenses or the legal position over the mining of texts. And so far as they can, libraries ought to ensure that they can mine their holdings. Unfortunately, the reality might be that some other entity will do the mining and charge the libraries for doing so. 9.2.9 Information Assistance. Let us adopt a form of thinking here. Let us characterize information intermediation in terms of tasks and control, or flow. Tasks consist of searching, recommending, paraphrasing, translating, etc. Control, or flow, is how the tasks fit together on particular occasions. There is sequential flow, which is where tasks follow each other in a sequence. There is conditional flow, which is where there is a condition, call it if, and if the condition is satisfied, i.e. is true, flow goes down one branch, one further sequence of tasks, and if not, the flow goes down another branch. Finally, there is loop flow, which is where a sequence of tasks repeats or loops either a given number of times or until a condition is satisfied. Given this structure, informal information algorithms can be constructed. For example,
is there a day of the week that the Musée d'Orsay in Paris is closed in July? Is there a day of the week that the Louvre in Paris is closed in July? If they are both closed on the same day, answer, in English, what day that is. Otherwise say which museum is open when the other is closed and what the relevant days are. Look up recent research on twisted spin. Summarize the best papers, no more than 5 papers. Present the summary at the level understandable by a graduate student in physics.
We can conceive of these in terms of flow and tasks, and so can LLMs. LLMs can take this kind of input in English, spoken or written, and answer it. The answers, July 2023, may be a bit rough. But it will be only months before the answers will be very good. In some. Shortly there will be information assistants that can combine information tools on the spot. Users will be able to mix and match tools. That might not matter to library patrons on all occasions of their uses of libraries. But the lives of researchers are going to be transformed. 9.3 Improving traditional cataloging, classification, and retrieval tools. The elephant in the room here is presented succinctly by Tamar Sada in her doctoral thesis and a series of papers including From Search to Discovery, Sada 2015. The argument is, the traditional approach required users to learn library systems and articulate the perfect template to launch a search which would then be guaranteed to produce a perfect result straight off. In contrast, the modern user could not care less about library systems. In their daily lives, they use Google search and do online shopping all the time. They enter the information discovery process in a sloppy and haphazard way, but get some, or many, results which are then honed to meet their needs. The process is familiar to them. Sada describes this. The designers of traditional library information systems, such as library catalogs and databases, were very focused on meeting the needs of librarians and expected that users would invest time and effort in learning how to use the system. The designers of discovery systems, driven by the needs of end users, strive to streamline the end-to-end process of finding and obtaining information and make it as simple and friendly as possible. Rather than offering multiple options to enable users to describe their information need, discovery systems offer users simple search interfaces but complement these with multiple post-search options for assessing findings, refining results, and navigating to other results of possible interest. The look and feel of the interface is similar to that of other information systems that are familiar to users, such as web search engines and online bookstores. Furthermore, recognizing that today's users spend hardly any time reading instructions, developers have made discovery systems very intuitive. Sada 2015, 216. So, we can look at the topic improving retrieval tools, but some improvements may be for librarians only. There is the view from Patrick Wilson and Karen Coyle that traditional cataloging theory omits the user from its concerns. Coyle 2016, Wilson 1968, Svenonius 1969. This view invokes descriptive power, describing the resource items that libraries have, and exploitive power, which evaluates and recommends items suitable for patrons or users on particular occasions. Cataloging does the former, but not the latter to any competent and enthusiastic degree. There is subject classification, but that has not been carried out very well. S. Berman 1971, Frick 2012. There are other library services and tools that help with exploitive power, for example, bibliographies, reference interviews, and similar. But librarianship to date has been weak on exploitive power. Relatively new computers-supported search engines, with ranked returns, and recommender systems are strong in these areas. But ML, especially large language models, have the potential to take this to new levels. Thomas Padilla writes,
Semantic metadata can be generated from video materials using computer vision. Text material description can be enhanced via genre determination or full-text summarization using machine learning. Audio material description can be enhanced using speech-to-text transcription, and previously unseen links can be created between research data assets that hold the potential to support unanticipated research questions. Padilla 2019, 12.
This is exactly right. We will supplement this in places and give detail to some of the suggestions. Over the millennia that librarianship has been practiced, librarians have developed many retrieval tools. Here are a few, supplemented with some modern techniques: abstracts, bibliographies, book reviews, catalogs, citation indexes, computer interfaces, controlled vocabularies, cumulative indexes, databases, dictionaries, encyclopedias, finding aids, handbooks and manuals, indexes, inventories, keywords, nomenclature, ontologies, outlines and syllabi, pathfinders, reference interviews, reference lists, registers, reviews, search engines, single entry term, phrase, or keyword, search boxes, subject, guides, summaries, tables of contents, textbooks, thesauri, web browsers. As we will see, ML will likely be able to improve most of these tools individually. See, as examples, Iris.ai 2023, Pickering et al. 2022. A different consideration is whether ML can replace some of the tools entirely. 9.3.1 NLP-inspired improvements. Most of the AI/NLP areas of value to librarianship are mentioned and described in Chapter 8. 1. Named entity recognition. 2. Topic modeling, text classification and automatic tagging. 3. Controlled vocabularies, thesauri, and ontological vocabularies. 4. Automatic indexing. 5. Text abstracts, extracts, key phrases, keywords, and summaries. 6. Sentiment analysis. 7. Author and genre recognition and plagiarism detection. 8. Text mining and question answering. 9. Machine translation. In general terms, these all make improvements to older techniques. But some bring features that are genuinely new. A. Topic modeling can identify new topics in huge corpuses of texts, e.g., in social media. B. Indexing can identify sources outside of the original indexed document. This could be useful for research. C. Sentiment analysis can be useful for recommender systems. For individual books, for authors, for genres. For individuals, for the patrons as a whole, trending books, and for collection development. D. Author and genre recognition and plagiarism detection. E. Text mining and question answering. F. Machine translation. 9.3.2 Metadata generation and automatic cataloging. Machine learning can certainly be used to create all the forms of metadata that are in use in librarianship today, i.e., it can do cataloging. See, for example, Griffey 2019, Corrado 2021. What would be likely here is interactive reinforcement learning or human-in-the-loop learning. That is, during the training process, professional catalogers would provide feedback as to how well the automatic system is performing. The catalogers would be part of the training. Of course, it is not easy to know what good cataloging amounts to, Snow 2017. In certain circumstances, automatic metadata generation has the potential to be very useful. For example, UNESCO has audio recordings that would benefit from having metadata. They have about 6,500 recordings in 70 languages, and some of the recordings are multilingual. What they have done in the past is that an intern listens to a recording and picks topics and personalities. There are ML systems that can do the speech recognition and transcription, for example, Whisper from OpenAI, OpenAI 2022b. Apparently, one of the challenges these systems can have is with crosstalk, e.g. meetings where several different people talk as and when they feel so inclined. 9.3.3 Some retrieval tools. The opportunities or possibilities here are extensive. We will address just a few examples. Producing a list of references that are actually cited in a text is a trivial computer science problem. There are many human-powered citation managers, e.g. EndNote, Zotero, and Microsoft Word, and all of these can produce bibliographies, here meaning reference lists, or citation lists. True bibliographies are another matter. A true bibliography is being understood in this context as being a list of the works used to write or produce the text, whether those works are cited or not. Producing a true bibliography is no easy task. The author or authors of a work can do it. But for third-party humans or computer programs, it is a challenge. Computational linguistics can classify texts, can identify the genre, can identify whether two works were written by the same author, can identify plagiarism, etc. But these methods, whether they use ML or not, mostly rely on what is in the text explicitly. Locating what is in the background that might have inspired the explicit text is a challenge of a different level entirely. As of 2023, it cannot be done. Paula Carina de Araujo and fellow authors, and, separately, Linda Smith, provide a good introduction to the vast area of citation analysis and citation indexes, Araujo, Castagna, and Jorlin 2021, L.C. Smith 1981. In brief, a reference is an explicit acknowledgement that one text gives to another, and a citation is reference received by a text from another. Citations and references can be used to build webs or networks between documents. Such networks, which often amount to citation indexes, can be valuable for a variety of scholarly purposes. Centrally,
1. They are tools for the scholars seeking knowledge, and 2. They are tools for the scholars studying science, including scientometricians and information scientists. Araujo, Castagna, and Jorlin 2021.
One point to note about traditional citation analysis is that what is being considered is actual citations made by human authors. These citations may be made for a variety of reasons. As Lizzie Gadd notes, the citation typing ontology lists 43 different types of citation, Gadd 2020, Peroni and Schotten 2012. Let us pick a semi-random 5 of these, is confirmed by, corrects, critiques, derides, and disagrees with. Consider a particular research paper, A, and another research paper, B. If the human author of A is conscientious and knowledgeable, she may cite B for any of the 5 or other reasons. But, nevertheless, given the vagaries of life, she may not cite B at all. However, the paper A may still be confirmed by B, or correct B, or critique B, etc. That is what the paper may do, objectively. A scholar of ideas, of intellectual history, of the development of the theories in a field, may mainly be interested in the relationships between A and B, not in whether the author of A cited B. Additionally, consider the time before it was the practice to make citations. Ancient Greek or Roman authors wrote texts that, for example, critiqued other texts. Human creators of citation indexes or analyses basically can only work with actual citations. But at this point, ML and NLP systems have a crucial advantage. They can scan the entire research literature and form a knowledge or information map of which papers confirm which other papers or deride which other papers, etc. They can skin the content as well as the gossip of actual citations. New knowledge mapping tools are, and will be, far superior to their traditional counterparts. See, for example, TAE 2022. Moving on. ML systems could write book reviews. With fiction, it could identify plots, characters, themes, whether the content was diverse, intended audience, and other aspects of the document or book. With nonfiction, it could assess quality by means of coherence, groundedness, truth and evidence, writing style, citations it uses, citations to it, and other indicators. Also, it could, using sentiment analysis and other NLP techniques, collectively assess, summarize, and evaluate reviews written by other agents, human or otherwise. Libraries make extensive use of databases. Almost all information about their own individual holdings will be held in databases. Access to these will often be via their catalog, which might be in the form of an online public access catalog. Also, there are any number of commercial and other databases that serve as access points to further resources outside an individual library's holdings, for example, to research papers, to legal materials such as citations and precedents. An academic library might provide access to hundreds of outside databases. Of course, databases will be used in the everyday administration and management of libraries, such as for patron and circulation records, for staff salaries, etc. Database theory is a specialist area, widely studied in computer science. Databases themselves provide organization to their contents. They also should be able to do so in a structured and provably correct way. They support CRUD operations, create, read, update, and delete. There is, or can be, plenty of automation in connections with databases, for example, with checking the data on entry, for format, reliability, etc., checking integrity, following a backup or archiving or compliance policy. It is not clear quite what role machine learning might have in this domain. ML can program a database. It can do any computer programming approaching the level of professional programmers. How good it would be a design is an open question. This is an area where there are many formal techniques, entity relationship diagrams, and the like, and ML would presumably easily master those. Machine learning can have plenty of relevance to the contents of databases, picking up patterns in the data for one reason or another, for example, identifying fraudulent transactions in a financial database. Somewhat similarly, in a library setting, machine learning will be able to identify usage patterns in the resources, for example, which resources are used by which segments of the patrons, and thus aid acquisitions and collection management. Traditional catalogs list all the materials held in a library. The lists will have data and metadata about the resources. If a library physically issues books and materials, a catalog might assist with lending, checking availability, placing holds, etc. All of these functions benefit, or will have benefited, from computer automation. The old-timey favorite card catalog was a technology to help the patrons find items among those materials listed in the catalog. As computers, networks, and automation came in, the card catalogs evolved into online public access catalogs, OPACs. OPACs steadily acquired additional functions such as access to materials in other libraries or in other formats like databases. OPACs are probably drifting off into the sunset, Wells 2021. There is a better alternative, the so-called discovery systems, such as Primo VE, Summon, or EBSCO Discovery Service. Tamar Sada writes,
Discovery systems provide access to a large, diverse information landscape of scholarly materials regardless of where the materials are located, what format they are in, and whether the library owns them or subscribes to them. At the same time, these systems typically offer simple, Google-like searching as the default option, to accommodate the expectations of today's users. With this type of searching, users do not spend much time formulating queries, and their queries often yield large result sets. Therefore, discovery systems focus on relevance ranking and on tools that help users easily navigate and refine result sets. Librarians have welcomed the advances in discovery services for their users. However, this new reality poses challenges to the practices that librarians have developed over the years and, in some cases, is at odds with the systematic, controlled approach to searching endorsed by librarians, SADA 2015.
With, for example, personalization and recommendation such as Primo VE, Summon, or EBSCO Discovery Service. LLMs can create dictionaries. After all, they will have seen massive amounts of text in its natural contexts. Many dictionaries provide examples in use. LLMs will be able to provide richer and more comprehensive examples. Right now, though, 2023, it would be usual to construct dictionaries by editing existing dictionaries. Merriam-Webster's dictionary, for example, is about 200 years old, and about 1,000 new words are added each year. Words are removed also. There are corpora collections of real-world text, for example, the Open American National Corpus, ANC 2023. Computer analysis of corpora tells which words are new and how frequently they appear, and also which words are drifting out of use. Then, presently, human judgment, assisted by computers, makes decisions on how to edit the dictionary. The whole process could surely be done by ML and LLMs on their own. The LLMs in question would presumably have some downstream training from human experts. The commercial companies such as Merriam-Webster do use artificial intelligence as examples to personalize the experience to the user and to provide usage examples and notes. There are encyclopedias that have in part, or in whole, been created by ML. 1. Wikipedia uses AI. This use may be directly involved with creation of text content or in support roles related to evaluating article quality, adding metadata, or generating images. Wikipedia 2023-0. 2. Wikimedia is using ML to help with images for Wikidata, Rady 2018. 3. Encyclopedia.com, Encyclopedia.com 2019. This is an access point, rather than an encyclopedia in itself. It gives access to 200 other encyclopedias and can search and summarize. 4. Numina Group's Warehousing Encyclopedia, Numina Group 2023. This is more of a glossary or catalog. ML-created encyclopedias could or should be completely up-to-date, accurate, and comprehensive. They might be expensive, biased, and with some entries that were hallucinations. A Pathfinder is
a subject bibliography designed to lead the user through the process of researching a specific topic, or any topic in a given field or discipline, usually in a systematic, step-by-step way, making use of the best finding tools the library has to offer, writes 2014.
The finding tools mentioned here include catalogs, bibliographies, indexes, abstracts, bibliographical databases, and search by author, title, topic, and keywords. Machine learning can improve Pathfinders in many ways. A. The whole task of producing a Pathfinder can be done automatically. B. It can personalize a Pathfinder to a user, instead of there being a single Pathfinder for many users. C. Its search will be better. D. It can find and follow topics even when those topics do not have their own metadata by having been cataloged by the library systems. E. Indexes will be better. F. Abstracts will be better. 9.4 Chatbots. Chatbots have been in use in libraries for at least 10 years, McNeil and New Year 2013, Weigert 2020. They are improving. They have the potential to do, or interface to, most of the current tasks where librarians interact with patrons. Most obviously here are reference interviews. There may be a loss of some personal touch, but the gain might be a tireless expert reference librarian for every patron, available 24 hours a day, 7 days a week. Another possibility is that of supplementing frequently asked questions, FAQs. After all, at the start of a freshman year at a college, there may be several thousand students wanting to ask the same routine questions, such as the opening hours for the campus libraries. Chatbots might also produce a thinning or abandonment of present-day library websites. A deeply structured website will often not be the best way of directing users to the resources on offer. Wikipedia 2022e, Thopolin et al. 2022. There may be a loss of personal touch. There may be a gain of personal touch. Some folk are really enchanted with chatting with chatbots. There is some evidence that chatbots outside a library setting do not provide a good customer experience. UJET.cx 2022b, 2022a, standard point. One benefit might be indefinitely many tireless expert reference librarians, enough for one for every patron, available 24 hours a day, 7 days a week. Librarians would be valuable, perhaps even necessary, in the creation of suitable chatbots. Likely the chatbots will use the GUS architecture with frames with slots, Bobrow et al. 1977. The frames provide the contexts, and the slots the values of the variable for the data, such as the questions and answers. Librarians have a better idea than most what the frames should be for a librarianship setting. 9.4.1 Reference interviews. Some librarians either are reference librarians or, as part of their duties, conduct reference interviews. Librarians here are acting as intermediaries between patrons or users and reference or information sources. A few years ago, the aim of a reference interview was to match a patron's needs to a single library's resources. Nowadays, the resources would be assumed to extend outside a single library, perhaps to all libraries and, indeed, to the Internet itself. Several sources provide the same instructional guide to librarians as to how to conduct a successful reference interview. Here is a typical outline.
Purpose: allows staff to match the customer's question to a relevant and useful source of information. The aim of the interview is to answer the patron's questions using the library's resources. Guide to a successful reference interview. 1. Approachability. 2. Interest. 3. Listening/inquiring. 4. Searching. 5. Follow-up. 1. Approachability. Pay attention to both your own and the customer's body language. Acknowledge and greet the customer as they approach the desk. Ensure the customer has your full attention. 2. Interest. Maintain eye contact. Find a confidential location for the customer to ask a question. Restate and rephrase the question. Speak in a relaxed tone. Make the customer feel comfortable. Nod your head when the customer starts to ask questions. 3. Listening/inquiring. Do not interrupt. Ask clarifying questions. Let the customer express their needs in their own words. Ask open-ended questions to probe about their information needs. Examples: tell me more about the sources of information you already consulted. Why do you need the information? How will you use the information? Remember, WORF welcoming. Listen carefully. Open-ended questions. Repeat their answer back to the customer. Follow-up to ensure they've found the information. 4. Searching. Keep the customer informed of the progress. Offer referrals. Offer to instruct the customer on how to ask clarifying questions. Do you want printed information that you can take home with you? Do you have access to a computer so you can look up sources online? 5. Follow-up asking the customer if they have everything they need ensures that the customer is satisfied with the transaction. If the follow-up questions indicate that the customer is not satisfied, clarify what information is missing. Offer to continue working on answering the question. Refer the customer to another organization if material is not available at your library.
The author dislikes the use of the word customer, but maybe that is just him. ML and LLMs can certainly excel at all this. Joseph Vinci has a useful discussion in his paper Virtual Reference Librarians, Chatbots, Vinci 2017. A caution, that paper was written before the advent of ChatGPT. 9.4.2 Virtual Services. There have been virtual reference desks, Ask a Librarian web pages, and Chat with a Librarian through a web page, more or less since the Internet expanded and became popular. Some of these have been retired. For example, the Library of Congress Virtual Reference Desk was retired around 2020. The LLM's complete changed the game on this. You can have ChatGPT on your smartphone. That is a virtual reference desk, without needing a library or librarians. As of June 2023, ChatGPT is not perfect with accuracy, providing references, and avoiding hallucinations. But it is improving all the time, and there are good reasons to suppose that ChatGPT with appropriate plugins will outperform any extant virtual reference desks. Librarians might work with ML researchers to create the plugins. 9.4.3 Chatbots as continuous user testing of a library's public interface. This might be controversial, and it certainly would need handling carefully. But chatbot transcripts would throw good light on what patrons actually do, or plan to do, while using a library's resources. For example, a web page with a large number of show height toggles, accordion widgets, may prove hard to follow. A chatbot leading a user through the page could provide feedback on this. 9.5 Release, produce, or curate training data. ML is only as good as its data. Training data is hard to come by. It needs to be plentiful, and it needs to be of high quality. For supervised learning, the data needs to be labeled accurately. Librarians are well placed here with all kinds of suitable data. They already have rich metadata on traditional resources, including shelf classification, subject classification, and indexes. And they can produce new kinds of data. For example, the ReadCoop projects to use handwriting recognition on archives of historical documents, ReadCoop 2021. These projects can involve creating and inspiring crowdsourcing to produce data at scale, e.g.
Transcribe Bentham is an award-winning participatory initiative which launched in 2010. Its aim is to engage the public in the online transcription of original and unstudied manuscripts written by Jeremy Bentham, his correspondents, and his amanuenses. UCL 2018.
Public librarians can inspire crowdsourcing. Many modern ML projects, especially large language models and foundation models, use crowdsourcing in their training. For this, they generally need ordinary people, but collectively the crowds would usually need to be diverse as to race, ethnicity, religious beliefs, sexual orientation, etc. Public libraries interface with many hundreds of thousands of exactly the kinds of folk that would be suitable, possibly even ideal. 9.6 Debunking, Disinformation, Misinformation, and Fakes. Librarians have always been active with information literacy, which is helping users and patrons to become more discerning and skillful in their approaches to information resources. We will discuss this again later. But, in addition to this more general raising of skills on the part of users, there is, or can be, a scrutiny of the actual resources themselves. There are problems aplenty nowadays with disinformation, misinformation, fake news, deep fakes and the like, Mazzaros and Goodset 2022. Traditionally, librarianship would not pass a view on the veracity of sources or on evidence. Librarians would remain neutral, for example, between resources on evolutionism and on creationism, and there are good free speech arguments for doing this. But there is considerable value now in fact-checking. Librarians already help patrons to fact-check, e.g., NAP 2021. Many libraries and library associations are deeply involved in fact-checking. Really, this is a part of epistemology, perhaps social epistemology. 9.7 Social Epistemology. Margaret Egan and Jesse Scherer introduced social epistemology as being
the analysis of the production, distribution, and utilization of intellectual products in much the same fashion as that in which the production, distribution, and utilization of material products have long been investigated. Egan and Scherer, 1952.
One core part of this concerns what we know, the true beliefs we have as individuals and collectively. Most of what we know individually comes from other people via recorded knowledge. Certain practices regarding that recorded information can promote or inhibit social knowledge, i.e., knowledge aggregated across individuals. As an obvious example, easy wide access to recorded information promotes social knowledge, whereas censorship inhibits it. Some qualifications are needed to this example. Too much information might overwhelm our attention and interest. A little censorship, or filtering, or curating, might highlight the pearls among the dark sea of many biased and unsupported opinions. Egan and Scherer, and other later researchers, such as Don Fawless, Steve Fuller, and Alvin Goldman, have seen the promotion of social knowledge as being a vital function of librarianship. Fawless, 2006, 2002, Fuller, 1988. Goldman, 1999, Egan and Scherer, 1952. Librarians are experts at traditional information acquisition and information provision practices. That is a good start. But machine learning is both going to provide more powerful tools to help with social knowledge and, perhaps a mixed blessing here, a vast amount more source material for those tools to be used on. Here is a conjecture about recorded text, especially new materials on the internet and on social media. The large language models, such as ChatGPT, Bard, and Bing, can write English and other languages, as well as native speakers. They can do so quickly, much quicker than native writers, and cheaply, much cheaper than native writers. Very shortly, tools from these models will be in the hands of anyone that wants them, as tools on the web or in word processors or standalone apps on smartphones, tablets, or computers. What the tools will produce will be plausible in terms of vocabulary and grammar. Some of the textual products will be information. Others will be misinformation. Some will be hallucinations. Some will be fiction, intending to be fiction. Some will be fiction, not intending to be fiction. It seems that ML source creators will be as ubiquitous as spell checkers are today. Every means of producing content will have available an LLM assistant. What might be roles for librarians in connection with ML and social epistemology? 1. Fact-checking. Help with identifying misinformation, disinformation, and false facts. 2. Help with reasoning. Many folk have trouble with reasoning with hypotheses, evidence, and truth. Indeed, one experiment showed that 50% of Harvard physicians can commit the base rate fallacy. The base rate fallacy is explained in Appendix B2. AI can help keep people on track. AI can construct proof trees from arguments and evidence. 3. There is the notion of Veritaism, or truth-centered epistemology, Kitcher 2002, Noir 2021, and from this the question arises of whether social epistemology needs to be veritistic. There is the need for input from philosophy. Once there is an acceptable answer to this, ML may be able to help. 4. There is the view, now becoming widespread, that peer review as used, for example, in scholarly publishing has failed. One proponent of this is Adam Mastriani, Econ Talk 2023. ML can do everything that peer review is supposed to do, check spelling, grammar, citations, diagrams and figures, calculations, originality, contribution to the research field, absence of plagiarism, etc. 9.8 Robots. For convenience here, we will divide robots into three categories: chatbots, humanoid robots, and non-humanoid robots. There may be some overlap of these boundaries. For example, a humanoid robot might have chatbot capabilities. Then, orthogonal to this, a physical library may be using robots or providing access to robots. Chatbots are discussed elsewhere, and there are many opportunities for librarians with chatbots. Humanoid robots are beginning to be introduced as companions and helpers to the elderly in rest homes. There are also some uses in nursing. Such robots are often mobile and can converse. The humanoid part usually includes human-like expressions of emotions and gestures. These can engender trust and reduce anxiety on the part of the people the robots are interacting with. Somewhat similarly to being helpers in rest home, robots have been trialed in public libraries. As examples of actual uses, being a teller of stories in storytelling sessions for children, being a greeter to the library and answering directional or locational questions to books or resources, Gwen 2020, Kim 2017. Non-humanoid robots, for example, welding robots used in the manufacture of cars, would usually appear as part of the automation of processes. There has been inventory control in general, using RFID labels and chips, since the 1980s. This means that it is relatively easy to automate closed stack systems, where the public do not browse the books on the shelves. The physical collection can be in the basement and automation will do the rest. RFID and similar technologies are also invaluable with open stack systems. A handheld scanner, or a wand, or even built-in systems, in the shelves or walls of the building, will find, for example, any book or identify that it is missing. Increasing use of automation may be useful, but there does not seem to be a large role for robots. As to libraries providing access to robots, robots are going to be an important part of our future. This suggests that librarians can help educate the populace by, for example, lending robots or having makerspaces with access to robots or having educational seminars on robots. In sum, it is unclear quite what might happen in general with humanoid and non-humanoid robots in libraries and what the opportunities might be. See also, Tela 2020, Tela and Ajani 2022. 9.9 Images. A considerable portion of ML concerns imaging or has images as its subject matter. There are various librarianship-related problems here, e.g. recognizing or classifying images, attaching metadata to images, searching among a collection of images, perhaps where the input is itself an image, and so forth. Images are reasonably important within librarianship. There are libraries with images as part of their collections. But also, many text sources, for example newspapers, have images or diagrams within their content. Additionally, there is film or video. Such sources can be digitized, and from there processed using ML for certain tasks. It all becomes a matter of numbers and patterns in numbers. Some modern foundation models are, or aspire to be, multimodal. This means that they can work with source and output in any medium, e.g. text, or images, etc. An example is Benjamin Lee et al. The Newspaper Navigator dataset, extracting and analyzing visual content from 16 million historic newspaper pages and chronicling America, Lee et al. 2020. They write in their abstract.
We introduce a visual content recognition model trained on bounding box annotations of photographs, illustrations, maps, comics, and editorial cartoons collected as part of the Library of Congress's Beyond Words crowdsourcing initiative and augmented with additional annotations including those of headlines and advertisements. We describe our pipeline that utilizes this deep learning model to extract 7 classes of visual content: headlines, photographs, illustrations, maps, comics, editorial cartoons, and advertisements, complete with textual content such as captions derived from the MET/Alto OCR, as well as image embeddings for fast image similarity querying.
We have here machine learning, crowdsourcing, additional annotations. On 16 million pages. Respect. Chapter 10. Librarians as Sentries. 10.1 Copyright and Intellectual Property. As librarians license access to content from vendors, we need to ensure that contracts do not preclude our users from conducting text and data mining research, algorithmically based research, and machine learning. Miller 2020. 10.2 Intellectual Freedom. ChatGPT tells us that intellectual freedom has several drawbacks, including 1. Misinformation and false ideas. People may spread false or harmful ideas that are protected under the umbrella of intellectual freedom. 2. Conflict with other values. Intellectual freedom may conflict with other values such as privacy, security, and safety, leading to difficult ethical dilemmas. 3. Limits to freedom. In some cases, laws and regulations may limit intellectual freedom in order to protect public interest or prevent harm. 4. Divide between different perspectives. Intellectual freedom may lead to a fragmentation of perspectives and ideas, making it more difficult for society to reach consensus on important issues. 5. Resistance to change. Some individuals and groups may resist new ideas and perspectives, leading to resistance to social and cultural change. OpenAI. 2023, ChatGPT wrote this paragraph. 10.3 Censorship and Algorithmic Curation. Librarians can defend against censorship. ML is not directly a censor, but many of the techniques it enables and improves, such as personalization, recommendation, search, can lead to inadvertent censorship. The techniques can lead to filters and to placing individual patrons within their own bubbles or silos of information to the exclusion of the wider world of information. Customization is good and will presumably be appropriate and well received by patrons. But censorship is bad. There needs to be a balance. Removing inappropriate and offensive content entirely can be good, but it is hard to draw the boundary lines. Social media are also present. One would not ordinarily think extensively about social media in the context of libraries, but social media is a gatekeeper to some, perhaps even most, of the information that students and patrons obtain. There is also the manipulative capabilities of algorithmic processes, the abilities of algorithmic processes to influence a person's thought, emotions, and decisions, IFLA 2020-5. In some ways, this is not a lot different to advertising or propaganda. But ML is more powerful and less obvious and transparent. Librarians might have a role as sentries here. They have a history of protecting patrons and to arm wrestling with censorship. Some AI tools improve access to information, but there is a need to check that the improvements are available to all, including to people with disabilities. There is also inadvertent censorship. ChatGPT tells us inadvertent censorship refers to the unintended restriction of information or expression due to various factors. Here are some examples. Technical difficulties, technical glitches, or failures in communication systems can unintentionally restrict access to information or expression. A. Overzealous filtering. Some internet filtering systems, designed to protect users from harmful content, can inadvertently censor legitimate information or expression. B. Misapplication of laws. Laws and regulations designed to protect national security, public order, or public morals can be misapplied, leading to the unintentional restriction of information or expression. C. Economic considerations. Economic factors, such as the cost of publishing or distributing materials, can lead to the unintentional restriction of information or expression. D. Social norms. Social norms and cultural biases can lead to the unintentional restriction of information or expression that goes against the prevailing norms and biases. OpenAI. 2023, ChatGPT wrote this paragraph. 10.4 Privacy. Centrally, this concerns users' behavior and patron data. Privacy is a core value of librarianship, American Library Association 2006, E. Berman 2018. The main justification for this is to allow patrons intellectual freedom. Lack of privacy and confidentiality has a chilling effect on user selection, access to, and use of library resources, American Library Association 2006. Modern computerized libraries typically use integrated library systems, ILS, sometimes known as library management systems, LMS, to manage their services. These systems collect data, some of it about individual patrons, e.g. name, age, address, email, phone, driver's license, gender, borrowing history, etc. E. Berman 2018. Outside agencies, for example credit reporting and credit card companies, also collect data about individuals. It is possible to collate data across different systems, for example to use library patron data in conjunction with credit card data. Collation like this data collected for one purpose being used without consent for another should never happen. But it would be wishful thinking to suppose that it never does. There are issues here of privacy and consent. Librarians might be watchful that ML applications meet the required legal and ethical standard. 10.5 Bias. ML systems can be biased, and often will be if they are LLMs pre-trained by self-supervision on large quantities of internet-sourced digitized text. Some of these biases can be corrected relatively easily by prompting, fine-tuning, or plugins. But it is helpful to all if it is known what the biases are. Librarians can be on guard to ensure that their services are fair, equitable, and do not commit harms of representation or omission. As mentioned earlier, librarians do manage bias in many aspects of their work, for example with collection development. Most of these traditional forms of potential biases are nothing to do with machine learning, nor have been caused by machine learning. However, ML may be able to help with redressing them. 10.6 Social epistemology. Most machine learning systems can make mistakes. Generally, they work in terms of probabilities and will not give the same answer twice. This means that there is a problem with reliability. Further, if the different answers contradict or are inconsistent with each other, some answers must be plain wrong. This means that there is a problem with validity. In research in general, if the researcher has an instrument that is unreliable and lacking in validity, typically that instrument would just be discarded. The probabilities here also concealed. An LLM would not ordinarily say there is a 70% chance of rain and a 30% chance of sunshine. Rather, it would say definitively it will rain about 70% of the time, and definitively there will be sunshine about 30% of the time. The LLM displays an exaggerated confidence that a user might have difficulty in reading and understanding. Librarians can help patrons with attitudes to information that ML systems provide. Librarians can guard against misinformation. They can ensure that the information provided to patrons is accurate, reliable, and up to date. Librarians can have a sense of the information and digital literacy among the community of patrons in their libraries. If there are shortcomings, the librarians can provide further guidance, education, and support, especially with the question of how ML impacts the information patrons receive. Going forward, ML is going to provide many systems and tools for librarianship. Librarians themselves can evaluate these tools to ensure they meet the needs of their patrons and the communities. 10.7 Chatbots. An eye needs to be kept on chatbots. There is the well-known historical example of Microsoft's TAVE from 2016, Wikipedia 2023 M. Once in the wild and available to all, this chatbot degenerated into sexist and racist garbage within a day. This is an old example now. Also, it was configured to learn from the people it was talking to, and bad actors set out to lead it astray. They succeeded. Chatbots can have several drawbacks, including A. Limited understanding. Chatbots are limited in their understanding of human language and context, leading to misunderstandings and inaccurate responses. B. Lack of emotions. Chatbots lack emotions and empathy, making it difficult for them to fully understand human behavior and respond in a meaningful way. C. No creativity. Chatbots lack creativity and imagination, which can limit their ability to provide innovative solutions to complex problems. D. Inflexibility. Chatbots are designed to follow specific scripts and rules, making it difficult for them to adapt to changing circumstances or new information. E. Reliance on data. Chatbots rely on data and algorithms to generate responses, which can perpetuate biases and perpetuate harmful information. F. Security risks. Chatbots can be vulnerable to hacking and other forms of cyberattacks, which can compromise sensitive information and put users at risk. G. Technical limitations. Chatbots can be limited by technical constraints, such as limited processing power, storage capacity, and connectivity. OpenAI. 2023, ChatGPT wrote this paragraph. 10.8 Personalization, paternalism, and parentalism. Search usually will rank the links it returns. If there is ranking, there is further opportunity for error or malfeasance. Most obviously, the finger is on the scales with systems that allow sites to pay the search providers for higher positions in the ranked returns. ML systems need to be scrutinized in these areas. 10.9 Images and facial recognition technology. Attaching metadata to images is going to have its adventures. It is going to make mistakes. There are going to be false positives and false negatives. What turns on this is an open question. A notorious example is from 2015 when Google Photos misclassified Jackie Alcine and his friend, who are both black, as being gorillas. It is not really known why this happened, nor, it seems, has it been fixed. Grant and Hill 2023. The author has had a mildly similar experience himself. In 2016, Richard Lee, a New Zealand man of Asian descent, had his passport photograph rejected by software because his eyes were closed. Lee, an engineering student, told Reuters, "No hard feelings on my part. I've always had very small eyes and facial recognition technology is relatively new and unsophisticated." Reuters 2016. Give him a medal for saying that. The present author is a New Zealander, and around 2016 he tried to renew his New Zealand passport and the passport robot rejected his photographs because his eyes were closed. A couple of matchsticks and Photoshop fixed that. Attention does need to be paid to the attachment of metadata to images. Facial recognition technology in a general setting is discussed earlier in section 5.7.3, Bullumwini et al. 2020, American Library Association 2018. Our guess is that it will be used in libraries, without controversy, wherever and whenever patrons need to establish their identities, e.g., when borrowing books. Tracking patrons is another matter. Attention needs to be paid to it. 10.10 Losing jobs. There is a standard answer to questions of automation causing loss of jobs. It is, automation automates routine repetitive jobs, thus freeing up workers to do more complex and valuable tasks. Of course, this does not mean that there will be no loss of jobs. There is a standard text on this question. It is Kenning Arlich and Bruce Newell's Thriving in the Age of Accelerations, a brief look at the societal effects of artificial intelligence and the opportunities for libraries. Arlich and Newell, 2017. It is slightly old in that since 2017 LLMs have opened the floodgates on what AI can do. Chapter 11. Librarians as Educators. 11.1 Information Literacy for Consumers of Information. Information literacy in the age of AI is a new beast. As always, there is the helping patrons and users navigate the interface between information and their good selves. But there is a lot more nowadays. Now we have machine learning, large language models, and algorithmic pipelines that might use biased data and might produce biased results. 11.2 Artificial Intelligence Literacy.
What does AI literacy entail? Alongside basic digital literacy and information technology skills, AI literacy usually begins with an elementary understanding of how artificial intelligence and machine learning work, what they can and cannot do. IFLA 2020, 10 Their emphasis.
Michael Ridley and Danica Pollock-Potts write,
Navigating the effects of AI as well as utilizing it in a responsible way requires a level of awareness, understanding, and skill that is not provided by current digital literacy or information literacy regimes. Ridley and Pollock-Potts 2021a.
Others express similar views. For example, Charlie Harper writes,
The privacy, or really lack thereof, and ethics of data collection and dissemination should become an integral part of information literacy services. Now that images, video, and audio can be faked in staggering ways, the reality of source origin is becoming increasingly messy, too. Facilitating and promoting critical thinking and awareness within the community is a must. Harper 2018.
Librarians have the opportunity to help the population with this new kind of information literacy. There are some new labels that are appearing here, for example, AI literacy, digital literacy, computer literacy, machine learning literacy, and even algorithmic literacy. Ridley and Pollock-Potts 2021a. Digital 2030-2022, Druga et al. 2019a, Carlson and Johnston 2015. We will come back to these names shortly. These literacies have two classes of potential students, library staff, and the patrons of libraries, i.e. the public at large, or students and researchers in colleges and universities. Then we may make a distinction between internal, which here means intellectual, and external, which here means social, understanding social in a wide sense. So, for example, a person has AI literacy at an internal level if they understand many of the kinds of AI software programs and possibly could even write them. Roughly, this would be college-level knowledge or competencies that include some AI or computer science courses. AI literacy at an external level requires knowledge of the settings or societal contexts in which AI is used, for good or for bad, and a reasonable grasp of how AI affects their own lives and that of societies as a whole. Even children can be AI literate at an external level. Back to the labels. We favor AI literacy. ML is where the action is, but machine learning literacy is a mouthful. Neither digital nor computer literacies are entirely accurate. Algorithmic literacy is unfortunate. It smears the word algorithm into a meaning it does not have, and then exhorts us to be literate about a topic that it does not itself define correctly. Nevertheless, no doubt algorithmic literacy will gain ascendance in the marketplace for labels. At which point we will go with the flow. Anyway, it is the external versions of the literacies that librarians need to learn themselves and teach to others. There is a literature on teaching machine learning. For example, the delightfully titled Can You Teach Me to Machine Learn? Solmont, Petitzes, and Cooperstock 2019. See also, Nori et al., 2019, 2023, Druga et al. 2019a. The literature, though, is sparse and the domain unexplored. It is not really known how to do it well. For librarians and libraries, probably hands-on workshops, tutorials, and coding classes would be a good idea. We have dealt with many of the components of AI literacy elsewhere, under different headings. But just to list many of the topics. 1. Algorithms and how they work. 2. Having a critical understanding of AI tools, for example, the ones mentioned in Chapter 5, and the information that they may provide. 3. Bias. 4. Privacy. Teaching people to understand how to protect their privacy in the context of machine learning is important. Also important is understanding the privacy policies of ML companies and ML applications. 5. Facial recognition technology. 6. Research guidance. Librarians could guide researchers in using machine learning tools to analyze their data. This could include providing advice on the appropriate algorithms to use, helping to interpret the results, and ensuring that the research is conducted ethically. 11.3 Data information literacy for producers of information. There is the topic of Data Information Literacy, Data Information Literacy Project 2023, Carlson and Johnston 2015. Jake Carlson and Lisa Johnston ask,
what data management and curation skills are needed by future scientists to fulfill their professional responsibilities and take advantage of collaborative research opportunities in e-science and technology-driven research environments? How can academic librarians apply their expertise in information retrieval, organization, dissemination, and preservation to teaching these competencies to students? Carlson and Johnston 2015, 2.
Roughly, researchers need to curate their data in such a way that the data is available to other researchers and society at large. Also, for example, funding sources such as the National Science Foundation require a data management plan for research that they support. This is an ideal area for cooperation between librarians and researchers. This time the librarians are helping the researchers as producers of information, not as users of information. Only a part of this general area involves, or might involve, machine learning. But some of it may well do. Lisa Johnston and John Jeffries discuss a case where civil engineering students put sensors on bridges to learn of the integrity of the bridges, Johnston and Jeffries 2015. That challenge may well involve machine learning. As noted earlier, machine learning data, safe for supervised learning, needs to be of a certain kind and style. 11.4 Changes in learning and teaching. Teaching and learning are changing in colleges and universities, particularly in areas like law and business. If curricula change, then there will need to be changes in libraries. Likely learning will become more personalized. If so, there will be learning data and analytics both of individual students, of instructors, and of groups and classes. Library use data will be part of this. There are initiatives on the use of AI in teaching and learning. See, for example, Office of Educational Technology 2023. 11.5 Scholarly communication. Jason Preem argues in his paper Beyond the Paper that
the journal and article are being superseded by algorithms that filter, rate, and disseminate scholarship as it happens. Preem 2013.
This is an interesting and important paper. Preem, writing in 2013, locates many of the changes and possibilities for change in the web and what the web enables, for example, share early, share often, filter, and crowdsource review. We could not agree more with the general thesis, but now we would locate the causal factors more with machine learning and LLMs. AI has the potential to remove peer review and possibly even many traditional journals. 11.6 Academic libraries collaborating with other university units. Academic libraries do this already. But ML is going to bring about big changes in teaching and research. The International Federation of Library Associations and Institutions, IFLA's 2020 Statement on Libraries and Artificial Intelligence, IFLA 2020-14, mentions as example collaborations Stanford University Library AI Studio, the University of Rhode Island's AI Lab in the University Library, and the University of Cincinnati Library's Digital Scholarship Center. See also, McKinsey 2018. A surprise is how few collaborations there seem to be. Most colleges or universities have a data science department or school. All universities have their libraries. Yet the visible collaborations can be counted on the fingers of one hand. 11.7 AI laboratories in the library. In 2017-8, the University of Rhode Island placed an AI lab in its library.
The library, as an interdisciplinary space that values inclusivity, is the ideal place for people of all backgrounds to learn about AI. Unlike a typical AI lab focused on research, the URI AI Lab will offer students and instructors the chance to learn new computing skills, and also encourage them to deepen their understanding of AI and how it might affect their lives, through a series of talks and workshops. The lab will offer beginner to advanced level tutorials in areas such as robotics, natural language processing, smart cities, smart homes, the Internet of Things, and big data. McKinsey 2018. Putting the lab in the university's library is strategic. Organizers hope that students majoring in different fields, from philosophy and ethics to computer science and biomedical engineering, will visit the lab and use it to brainstorm about important social and ethical issues today and create cutting-edge projects. Rhody Today 2017.
The experiences of the AI lab, up until 2022, are described in Decker, Feria, and Mundell 2022. It seems that there has been such a demand for the AI lab, and for data science as a whole campus-wide, that the university is considering its options. 11.8 Automated Decision-Making. The European Union, EU, has a Generalized Data Protection Regulation, GDPR, summarized in Wolford 2018. It is a law which applies to and protects EU citizens worldwide. It came into effect in 2018. Of particular interest to us is Article 22, which in part reads,
Art. 22 GDPR Automated Individual Decision-Making, including Profiling 1. The data subject shall have the right not to be subject to a decision based solely on automated processing, including profiling, which produces legal effects concerning him or her or similarly significantly affects him or her. 2. Paragraph 1 shall not apply if the decision, further text omitted here, GDPR 2018.
Profiling in GDPR means
any form of automated processing of personal data consisting of the use of personal data to evaluate certain personal aspects relating to a natural person. Thus, profiling should be construed as a subset of processing, under two conditions: the processing is automated, and the processing is for the purposes of evaluation. Goodman and Flaxman 2017.
Article 22, in the context of surrounding text and definitions.
Restrict S. Automated individual decision-making, that is, algorithms that make decisions based on user-level predictors, which significantly affect users. The law. Also effectively create a right to explanation, whereby a user can ask for an explanation of an algorithmic decision that was made about them. Goodman and Flaxman 2017, 1.
European law is European law, of course. But, nevertheless, GDPR is the result of deep consideration and analysis. It highlights the need for caution with use of personal data to produce decisions that affect people and the need for explanations of individual decisions that are made. Automated decision-making, ADM, using data about people as input and producing decisions that affect people as output, has been around for a very long time. For example, the Constitution of the United States requires that there be a census every 10 years. The results of this census determine how many seats each state has in the House of Representatives, among other things. Processing data on this scale used to be a nightmare. Processing the 1880 census took 8 years, Roberts 2019, 100, and 1889. Herman Hollerith received a patent for the art of compiling statistics. It was a patent for the punched card.
A hole is thus punched corresponding to person, then a hole according as person is a male or female, another recording whether native or foreign born, another either white or colored, etc. Hollerith 1889.
The data about each individual person was entered on a single card as punched holes. But then the data could be aggregated by running through the cards and using an electromechanical device to detect the relevant holes. The data also could be combined across categories. For example, were you to have an interest in white female carpenters, it was essentially trivial in principle to determine how many there were in a region or a state or, indeed, in the United States. Hollerith cards were taken up by wider businesses and commercial concerns, and the processing techniques led directly to the formation of IBM and the standard IBM 80-column punched card. Hollerith and his card won the 1889 Bureau of the Census competition to mechanize the process of conducting the census. The 1890 census was automated. Thus, there has been ADM for a while, maybe for 130 years. You can see the strengths and weaknesses of this original automation of the census. It makes viable a very difficult practical problem. There should be few or no errors in the actual processing of the stacks of punched cards. Additionally, the actual processing is completely transparent and, in principle, could be inspected by anyone. But the data needs to be sound. If the data entry for an individual punches a hole for farmer when the individual is actually a carpenter, garbage is part of the input and the results of that garbage in potentially can appear in the output as garbage out. Even worse, if groups of people are not even included or properly represented in the census, there certainly could be bias or unfairness in what comes out. Nowadays, ADM has spread far and wide. Not all such decisions involve data about people as input, not all directly affect people as output. Not all involve machine learning. In fact, probably machine learning forms a relatively small, but increasing, part of ADM. After all, powerful machine learning has been available only for maybe 5 to 10 years. Here are some examples where machine learning may place a role in ADM. 1. Autopilots on airplanes, and similar technologies on ships, trains, and motor vehicles. 2. Many decisions in the financial realm, such as investing, the identification of suspect financial transactions, credit card or mortgage eligibility, and what interest rates those eligible are entitled to. 3. Medicine, identification of possible positive indicators of skin or breast cancer. 4. The behaviors of industrial robots. 5. Military, robotics on the battlefield, including unmanned systems and vehicles of various kinds. 6. Providing evidential input to sentencing decisions in criminal trials. 7. Various decisions involving employment, e.g. interviews, promotions, remedial interventions. 8. Making suitable chess moves to be a companionable opponent or to be a tutor of the appropriate level. 9, and many, many more. Some of these types of decision-making involve partnerships with humans. Humans may have overrides, may make the final choice or decision, etc. The strengths and weaknesses here are similar to those of the original census automation. But there are differences. Many of the systems, or their intellectual aspects, are owned by private companies, sometimes very large companies. A result of this is that often the systems are proprietary and are trade secrets. With this, transparency can disappear. Outsiders may have no way of being assured that the actual processing is sound. When it comes to machine learning and large language models, for example, even the companies and their researchers can be in a position of not really knowing how their complex systems work, if, indeed, they do work. In this case, transparency is not being hidden by companies, it is simply not available. A factor here is that large language models, for example, are so expensive to establish that only the largest companies or the government have the resources to create them and do research with them. Universities do not have the money to become involved directly. In many fields, one thinks of universities as being able to be qualified and intelligent, honest outside agents. But this is not true for advanced machine learning. The universities cannot participate at all at a core level. Then there is an important difference regarding the data. In immigration controls in airports, and similar, the government uses machine learning face recognition technology to scan the incoming crowds for persons of interest. The government does not seek anyone's approval or consent to do this. This is similar to gathering the original census data back in 1890. There is a social contract between members of the community or society that gives implicit consent from members of that society to their government to carry out various governmental tasks and procedures. But the situation with private companies is different. If you walk into a shopping mall and the mall scans your face, without your knowledge or informed consent, how is this right or ethically appropriate? In sum, attention needs to be paid to transparency and the uses of data. There is a lack of insight, a lack of transparency, and often a lack of informed consent. Putting this right perhaps falls to many parties, to the creators of the systems, to the makers of laws, to educators, and to the citizenry at large. Several countries, or groups of countries, do have laws. For example, as we have seen, there is the European GDPR. The USA does not have a relevant all-encompassing laws. Librarians certainly can play a role, Ridley and Pollock-Potts 2021a. Assume so, what can they do? The librarians can become knowledgeable themselves. The Masters of Library and Information Science, MLIS, degree, which is the union card for advancement in professional librarianship, might include courses in the wider aspects of machine learning. None do, at the moment, 2023, in the USA. Libraries, as institutions, can offer opportunities to their staff to increase their knowledge in this area. This might include courses, workshops, hands-on sessions. Then the librarians might be alert to inform their patrons about surveillance, consent, privacy, automatic decision-making, etc. 11.9 Explainable Artificial Intelligence, XAI. There is a research field, Explainable Artificial Intelligence, XAI, that has direct relevance to automated decision-making. Exposure to the ideas of explainable artificial intelligence, XAI, is of benefit to folk trying to educate others about machine learning.
Explainable AI is machine learning that has the property of being easily understood by humans. Wikipedia 2023d.
What ML systems can tell us is that certain observable features, feature data, are connected with other observable labels, label data for example, that being written by J.K. Rowling is correlated with being a popular book. Sometimes an ML system will tell us the labels, the predictions, without being able to tell us of the specific features that it used in its inference or calculation. In these cases, the ML system is a black box. You give it a book, the features of a book, and it will tell you if the book will be popular. It is an oracle. Henceforward, here, as an abbreviation, Oracle MLs. At this point, we will take a brief detour into two areas of philosophy, the philosophy of knowledge, epistemology, and the philosophy of understanding and explanation. We want to distinguish knowledge from right opinion. This is a distinction from Plato's Meno, amplified by John Stuart Mill's work on freedom of speech, Plato 380 AD, Mill 1869. Nowadays, right opinion would probably be more usually described as being true belief. Plato defined knowledge as having three components.
Knowledge needs to be true. It needs to be believed. It needs to be justified.
An Oracle ML might provide right opinion, but it does not give knowledge. For knowledge, the knower has to have evidence and be able to provide a reasoned defense, or explanation, or justification of the known. In brief, the knower has to be able to give the reasons why. Socrates argued
that true opinions, while they abide with us, they are beautiful and fruitful, but they run away out of the human soul, and do not remain long, and therefore they are not of much value until they are fastened by the tie of the cause, when they are bound. They have the nature of knowledge, and they are abiding. And this is why knowledge is more honorable and excellent than true opinion, because fastened by a chain, Plato 380 AD, 98.
An oracle does not give knowledge. It does not give causes. Then, what, in this context, is understanding?
A simple but plausible answer given by contemporary philosophers of science is as follows. To understand a phenomenon is to grasp how the phenomenon is caused. Strevens 2013.
The phenomena of interest here is how the successful ML systems produce the correct predictions that they do. To understand, we need to know the causes at work. With oracles, the causes are exactly what we do not have. Hence, to address these considerations, there is the existence of the research field Explainable AI, XAI, with its own techniques and methods. Space does not permit extended discussion here of XAI. There are actually two causal problems with oracles. There is the problem of specific predictions, understanding why a specific prediction has been made in a particular case, and there is the problem of understanding how a given oracle works as a whole inside its black box. An example of the first problem is when a radiologist works in partnership with an ML system to assess a patient and to diagnose possible cancer. The radiologist and the patient need to know the basis of, or evidence for, the ML system's prediction. The reason for that need is that knowledge is better than right opinion. Knowledge is better for trust, ethics, respect for human beings, decision-making, regulatory and legal requirements, etc. An example of the second problem is that the designers or programmers of the radiology image diagnosis system should understand how it works. That would help them going forward to assess and improve the system. Strevens 2013. Elsewhere, we do negotiate our lives using correlations, right opinions. The farmer puts fertilizer on crops, we take aspirin for headaches, and a majority of us avoid smoking for health reasons. Some of these connections are undoubtedly causal, but we usually do not know of the details of the causality. Often, this is the best we can do. The phenomena, the laws, if there are any, the initial conditions, and the interactions of these, are all intertwined and complex. Often, they are also probabilistic. Basically, the systems are close to being black boxes. If XAI can do as well as agriculture and medical science, that might be good enough. Chapter 12. Librarians as Managers. 12.1 Coming on board. Libraries need management, and many librarians have management duties. Of course, They are usually assisted in these duties by computers and general library automation. The use of AI or ML in this setting would be a step further. Amanda Wheatley and Sandy Herviews have published an environmental scan of the use of AI in academic libraries, Wheatley and Herview 2019. Their appraisal is bleak. Here are some quotations from the Wheatley and Herview paper, offered without comment or judgment.
What is perhaps the library's best-kept secret has been its slow uptake on automation and digital technologies. On the possibility of libraries being run by machines, this unsettling reality should have awoken librarians. Instead, the profession reacted as it did to most technological revolutions: it waited. In fact, it is still waiting. The absence of scholarly research on AI-related technologies in libraries is not to be unexpected. Libraries have suffered from issues on the adoption of digital technologies and a general resistance to change throughout the 20th and 21st centuries. The progression of industrial and office automation paved the way for libraries to adopt similar technology, yet this adoption was always years behind the current trends. The current state of artificial intelligence in academic libraries has proven to be nearly non-existent.
Separately from this environmental scan, there are literature reviews that range wider than academic libraries. Rajesh Das and Muhammad Islam, in their systematic literature review of the application of AI and ML in libraries, identify in the publications the following 10 themes: R. K. Das and Islam 2021. 1. Collection building and management. 2. Processing in libraries. 3. Circulation and user studies. 4. Reference service. 5. Library administration. 6. Library customization and retrieval. 7. Research and scholarship. 8. Service quality and innovation. 9. Intelligent agents for information search and retrieval. 10. Study on implementation and existing technologies and solution. Their review is backward-looking, of necessity. It is considering what has been done prior to 2020 and what AI and ML techniques were used to do it. There is also Andrew Cox, Stephen Penfield, and Sophie Rutter's The Intelligent Library, thought leaders' views on the likely impact of artificial intelligence on academic libraries, Cox, Penfield, and Rutter 2019. This does have valuable content. Its editorial summary is excellent. But it is old, and it is not clear how well informed the 33 thought leaders were around 2018. One of them did not know what artificial intelligence was, and none of them knew about large language models, nor did the rest of us. IFLA is the International Federation of Library Associations and Institutions. It styles itself as the global voice of the library and information profession. Its 2022 Trend Report update has no mention of artificial intelligence or machine learning, Al-Badi et al. 2023. IFLA does have its earlier statement on libraries and artificial intelligence, which is very good, IFLA 2020. Barbara Wood and David Evans write in their paper Librarians' Perceptions of Artificial Intelligence and Its Potential Impact on the Profession.
The results of our survey point to an overwhelming sense of complacency among librarians in regard to the transformative/disruptive effects of this technology. For the past 35 years, academic libraries have successfully embraced computerization. Why is it that, at this time, we have our heads in the sand? We liken it to the climate change debate. The data is there, but we choose to ignore it, Wood and Evans 2018.
For us, it is worthwhile for us to consider aspects of these themes which we have not considered elsewhere. In Chapter 8 the following topics were mentioned: workflow and improving service. A. Optimize the use of space, and, indeed, other resources. B. Robots. C. Mimicking librarian experts' behaviors. We are interested specifically in machine learning and artificial intelligence, not in plain automation. We are using the R. K. Das and Islam 2021 as the skeleton for this. 12.2 Data and Analyses. There will be data on resources, processes, user behavior, and more. From these, there can be predictive analytics. This identifies past usage patterns and trends as input to predict demand and need. It could be looking at many types of data as input: demographics, time of day, time of year, e.g. exams, summer breaks. With machine learning, it does not really matter how rich or apparently irrelevant the types of data. After training, anything known that is not connected with the correlations will just be given weight 0, i.e. discounted. A. User behavior analytics. This is data on what the patrons are doing, either individually or collectively. Attention needs to be given here to privacy or informed consent. Anonymous data, for example on which books are frequently checked out, can help with decisions on which books to keep physically in the stacks and which to store elsewhere, perhaps off-site. In contrast, recommendation systems will work better with information tied to patrons individually that still can be kept anonymous. B. Learning analytics. In cases where libraries are serving students, faculty, and research, there can be data on what resources the patrons use and how they use them for the purposes of teaching and learning. In turn, this can be used to improve the process of education. There is a large and burgeoning field: artificial intelligence in education, AIED. See, for example, Stanford HAI 2023A. Librarianship will have a role in this. That role will extend to school libraries and public libraries. 12.3 Evidence-based librarianship. When making decisions, evidence-based practices encourage the use of the best available evidence, in conjunction with expertise and attention to values. Wikipedia 2023c. This approach tends to downplay tradition, especially when no one knows why the tradition is as it is. There is evidence-based library and information practice, (IBLIP), with supporting books, research articles, and a journal. For example, Jorland 2011, University of Alberta Library 2023. Maybe now is its time. There is now plenty of data, and ML can analyze a quantity of it in a way that no human can. Of course, the management and administration of libraries used any amount of data prior to the advent of IBLIP. But now there is much more data and the existence of ML that can interact with that data intelligently. As mentioned many times, ML can deal with volume in a way that collective human resources cannot. 12.4 Data-driven decision making. 12.4.1 Collection, building, and management. ML can analyze the collection and its uses. Predictive analytics can be used as part input on decisions on which materials to purchase, keep in the collection, or weed or discard. It can help with resource allocation. The analysis would take input from availability of materials in other libraries or the needs of the library's users. See Litzy and Malden 2018. 12.4.2 Circulation and User Studies. Service, recommendation, personalization, and AIED all have relevance here. ML together with the data analytics mentioned earlier have the potential to affect improvements. 12.4.3 Processing and Libraries. AI can help with many of the processes that are part of librarianship. Most of these have been mentioned earlier in this text, including cataloging, classification, acquisition, archiving, digitization, transcription, translation, indexing, and summarization. 12.4.4 Research and Scholarship. The view here is that shortly the information discovery techniques and tools are going to be far superior to the ones we have today. We have amplified on this thesis throughout this text. What managers should do is to support the use of these tools. 12.4.5 Service quality. There will be improved metrics on most aspects of service. Being able to measure how good service is does not of itself guarantee good service. But whenever insights or innovations come to the fore, it is good to know whether they actually do make service better. 12.5 Acquiring the appropriate AI tools. The managers can acquire the relevant AI tools. IFLA makes a suggestion that would kill another bird with that stone.
Libraries can also support ethical AI research and development by their procurement choices, purchasing AI technologies which abide by ethical standards of privacy and inclusivity. This would both reaffirm the trust of users in libraries and send a message to the AI research field by increasing the demand for ethical AI technologies. IFLA 2020-2.
12.6 Analysts and staff. There is a shortage of skills and awareness.
The demands of responding to such changes may reveal a significant skills gap in the sector. We know there is already strong demand in the economy for data scientists for data analysis and visualization. Perhaps some librarians will be required to develop these skills, or at least awareness of different techniques and how they need to be supported. These demands are a challenge because they prompt librarians to learn more about IT and quantitative data analysis, including statistics. In a relatively low-paid sector, we may be unlikely to attract people with stronger STEM backgrounds to the profession, while those in the profession are typically from an arts background. More optimistically, we can say there will also be a need for librarians as data curators to take on new data. Cox, Pinfield, and Rudder 2019-17.
Foundation models have given us all a break here. You do not have to be a programmer or a mathematician to use, develop, or configure LLMs. You can even be from an arts background. So-called prompt engineering makes many things possible. We will look further into that in Appendix A. 12.7 Fear of AI. Within the library profession, there does seem to be a fear of AI, as evidence, see, for example, Cox, Pinfield, and Rudder 2019, Ex Libris 2019. Ex Libris invites us librarians to be liberty leading the people, Wikipedia 2023
Embracing AI not as users, but as active players to fight the risks of bias, misuse, and discrimination. If libraries take an active role in the implementation of artificial intelligence applications in the information management landscape, then they can help programmers find the best data for their algorithms. Once they assume the leading role, librarians can be co-creators of an intelligent information system that respects the sources, engages critical inquiry, fosters imagination, and supports human learning and knowledge creation, according to Catherine Nicole Coleman. AI solutions can also facilitate both more process transparency and greater data control, with libraries able to safeguard their most important principles and maintain trust, neutrality, freedom of expression, mindful media consumption, and equal access to information. While promoting digital inclusion and data privacy, advocacy should not be directed at maintaining traditional librarianship, but in influencing the development of the emerging information systems. Ex Libris 2019.
Chapter 13. Librarians as astronauts. 13.1 Astronaut Training. Well, you are in a good place. To do creative work with foundation models, you do not need to know anything about machine learning or computer programming. You do not even have to have any domain knowledge about the area you are going to work in, which we are assuming here to be librarianship. The foundation model you use will have all the knowledge that is required. Your role is to ask it in ordinary natural language to prompt it to do whatever you are looking for. Over the past 20 years or so, many librarians have become absolute experts at using search engines, say Google Search. Now there are new kids on the block, foundation models or large language models. It would not be a bad thing at all for many librarians to become absolute experts at LLMs. 13.2 Why should you learn how to do it? 1. Gives you understanding. 2. Allows you to teach others. 3. Allows you to produce apps. 4. Allows you to work with ML professionals. 13.3 What are the real creative possibilities? This is hard to know, stating the obvious. 3 areas where modern machine learning might have a distinction advantage over the incumbents in librarianship or in information curation and provision are data visualization, chatbots, information discovery, and text data mining. Data science making sense of data is important. Having the right representation of the data is often critical to understanding that data and seeing how to reason with it. The key point was made by Jill Larkin and Herbert Simon in their paper Why a Diagram is, sometimes, worth 10,000 words. They suggest that informational equivalence should be distinguished from computational equivalence, Larkin and Simon 1987. The distinction can be explained by means of an illustration. Donald Norman drew attention to a famous example of 2 games, Norman 1993. In the first,
you and your opponent take turns in choosing and selecting single, previously untaken, numbers in the range 1, 9, and the winner of the game is the first person who has 3 numbers that sum to 15. So you try both to get numbers that sum to 15 and also to prevent your opponent from getting such numbers.
In the second you play tic-tac-toe, or noughts and crosses. Now, the first game we would find awkward and might lose from time to time, until we devised a suitable representational scheme. The second is trivial, and an attentive adult would never lose a game. But the 2 games are the same. They are different representations of the same game. If the numbers are laid out as though they were on a tic-tac-toe board.
618. 753. 294.
Then the problem of finding 3 numbers that sum to 15 is exactly that of finding 3 in a vertical, horizontal, or diagonal line. Any information as to the board state, or to the numbers selected, is exactly intertranslatable back and forth between tic-tac-toe representation and number-selected representation. There is information equivalence. But humans can manipulate and compute with one representation much more easily than the other. And, interestingly enough, a computer, or a computer program, would be more at home with the numeric representation as opposed to the 2-dimensional board representation. Information opens up different possibilities for an agent depending on how it is represented. This is matter of the manipulations, operations, and computations that the depiction facilitates. A good collection of historical depictions of statistical data can be found in Michael Friendly's Gallery of Data Visualization, Friendly 2007. Machine learning may well be able to learn the best ways to represent data. Let us sketch some territories here. Insofar as this concerns diagrams, as it would for education and for research by humans, the area of interest is cognitive psychology and heuristics. Insofar as it concerns computer processing, it would be a matter of data structures and algorithms, parts of computer science. Librarians may be fine with either of these, but they are a little outside librarians' bailiwick. Chatbots have been discussed extensively in this text. Certainly, chatbots in libraries represent an opportunity, possibly even a research opportunity. But chatbots for the purpose of service are going to be everywhere. It may be hard for librarian developers to keep themselves clear of the development stampede. Information discovery and text data mining are both gifts to librarians. Librarians know from text. We will amplify shortly on one aspect of this possibility. 13.4 Sitting in your tin can. If you are going to sit in your tin can, you could think about how ML might provide new ways to interact with library resources. You could think about interactive games and simulations that might help with access or with AI literacy. You could think about many things. 13.5 Exploring World 3. 13.5.1 Undiscovered Public Knowledge, UPK. In 1986, Don Swanson wrote as the abstract to his paper Undiscovered Public Knowledge.
Knowledge can be public, yet undiscovered, if independently created fragments are logically related but never retrieved, brought together, and interpreted. Information retrieval, although essential for assembling such fragments, is always problematic. The search process, like a scientific theory, can be criticized and improved, but can never be verified as capable of retrieving all information relevant to a problem or theory. This essential incompleteness of search and retrieval therefore makes possible, and plausible, the existence of undiscovered public knowledge. 3 examples intended to throw light on the logic of undiscovered knowledge are constructed and analyzed. The argument is developed within the framework of a Popperian or critical approach within science and on Popper's distinction between subjective and objective knowledge, the distinction between World 2 and World 3. Swanson, 1986.
The referenced work of Karl Popper can be explained thus. Popper had introduced in the idea of 3 worlds, World 1, the physical world, World 2, the mental world, and World 3. The world of objective contents of thought, especially of scientific and poetic thoughts and of works of art. World 3's objective knowledge contains the contents of books and libraries, not the physical books, World 1, nor the mental ideas conjured up by the books, World 2, but the contents of the books understood as the objective assertions they make. See Epistemology Without a Knowing Subject, Popper, 1968. World 3 objects can stand in logical relations one to another. One book may contain the assertion Leda is a swan. Another book may contain the assertion all swans are white. Those 2 books together, considered as a combined whole, entail the consequence that Leda is white. Swanson instantiated and generalized this in the following way. Suppose some recorded research tells that process A causes effect B, and some entirely different recorded research tells that B causes effect C, then A causes C, and this, perhaps hitherto unknown, relationship can be discovered by looking at the recorded research. This is an example of undiscovered public knowledge, UPK. A real scientific example that Swanson offered from 1986 is that it was known, as recorded objective knowledge, that A. Fish oil reduces platelet clumping, B. and reduced platelet clumping is, C. of benefit to patients with Raynaud's disease. But it was not known as objective knowledge, i.e. published anywhere as recorded knowledge, that A. Fish oil can be, C. of benefit to patients with Raynaud's disease. That relationship can be discovered without entering a laboratory. It can be discovered without leaving a library.
Usually, different assertions and findings need to be assembled across documents to create a new coherent assertion, much as different pieces of a puzzle are assembled to create a single picture. Smallheiser, 2017, 3.
We should keep in mind here that all knowledge is fallible and conjectural. So that when we appear to discover that fish oil helps with Raynaud's disease, we are discovering a new conjecture that apparently no one had proposed earlier, and that conjecture would need testing. If its components had been thoroughly tested and were reliable, it may be that further testing could be minimal. That would depend in part on what the practical consequences would be of trusting the hypothesis. In the case of medical treatments and drugs, there are established protocols. It may be that the apparent conjecture from UPK had been known and discovered earlier. Researchers looking for treatments for Raynaud's disease may have had hundreds of conjectures as to what might be suitable, and their problem might have been how to spend their time and money. In this case, the ABC example given above screams loudly, try fish oil. UPK is still valuable. There are other kinds of UPK, Smallheiser, 2017. There can be publications that no one currently reads. These may be publications in truly obscure journals or in outlets that retrieval systems have trouble in finding, perhaps due to poor indexing or metadata. Investigators in these areas often talk of one-node or two-node searches or of open or closed searches. If the search starts with process A and is trying to find anything it relates to, that would be a one-node or open search. If the search starts with two processes A and C and is trying to find A to B that connects them, that would be a two-node or closed search. Don Swanson was a librarian. More strictly, he rose to being dean of the Graduate Library School of the University of Chicago. 13.5.2 Literature-Based Discovery, Text-Based Informatics. The seminal work of Don Swanson has been generalized and developed to form literature-based discovery, sometimes called text-based informatics. This is used widely in bioinformatics and medical informatics. See, for example, Crichton et al. 2020, Morrow 2023, Sebastian, Sue, and Orame 2017, Thalakaran, Faulkner, and Adepada 2020, Wikipedia 2023i. A consideration of importance to us is that literature-based discovery until about 2020 used what we now would regard as being primitive bibliometric tools. Computers were used, and Google-style searches. It used authors, titles, keywords, subject headings, etc. But 2023 machine learning, especially LLMs, open up new possibilities. No doubt, UPK researchers are onto LLMs already. But the target domain is vast, every book in every library. There are opportunities for all. 13.5.3 A message to librarian astronauts.
The growth of scientific knowledge is usually thought of in terms of wresting new discoveries from the physical world. World 1, admittedly a world that offers unlimited opportunity for discovery. But it should be of interest to librarians to notice that World 3 also qualifies as an endless frontier and to understand how and why this is so. Swanson 1986, 117.